So I want to say good morning, everybody. My name is Eric White. I'm the director of the Placer County Air Pollution Control District. I think most of you probably know my predecessor, Tom Kristoff, who retired in December. So it's with great pleasure that I take over the reins. And one of the very important things we're working on was this project. And so I'm very happy we're all able to get together today to talk about where we are in terms of the development of the protocol, to get your feedback on the protocol, and provide some input and direction to us and the steering committee team so that we can continue to move forward on developing and finalizing this. So, but before we do, I think it'd be a really good idea to do some introductions. Certainly for myself, since there's a lot of new faces for me, and for those on the phone as well. So again, this is Eric White with the Placer County Air District.
Bruce Springsteen, Placer County Air Pollution Control.
Balchanko, SMUD, Sacramento Municipal Utility District.
Fred Tornator, TSS Consultants.
Russ Henley, California Natural Resources Agency.
And David Saw, University of San Francisco, and Spatial Informatics Group.
Thomas Rupert, Spatial Informatics Group.
Jason Coe with Forest Service.
Steve Brink, California Forestry Association.
Ashley Conrad-Seda, Cal EPA.
Dave Sapsis, Cal Fire.
Chad Mason, Forester, TSS Consultants. Steve Eubanks, I work with the Air District.
Shannon Haroon, Placer County Air Pollution Control.
Right. So, folks on the phone, do you guys want to introduce yourselves real quick?
John Battles from UC Berkeley.
That's Keith Lake, Fire.
Mark Perry Bird.
From Proctor Force.
Well.
Bonnie Toriano, Air Resources Board.
Nick Ensis, Sierra Nevada Conservancy.
Matt Hurto, University of New Mexico.
John Gunn, Spatial Informatics Group.
Shane Romso, Spatial Informatics Group.
Bill Kinney, California Energy Commission.
Sounds like we got everybody. So welcome everyone on the phone. Just a quick overview of the agenda for this morning. So Bruce Springsteen of my staff is going to provide an overview of the project and a quick update on where we are. And then we're going to turn it over to Thomas and David with SIG to walk through a summary of the protocol and then to dive into some of the details on specific topics with that. And then once we work our way through that, then Bruce, who will be keeping some notes, will talk about our next steps and how we move forward on incorporating what the input we get from you all today into the next draft of the protocol. So with that, yes, Ashley, yes.
Interjection. Did you already do emergency stuff? But
I did not do emergency stuff, although I know the emergency, yes.
I figured you do. But just because we're in our building, if you need restrooms, actually, just go out this door and down the hallway, and they're on the left. Men's first, women's second. And if we hear an alarm and we need to evacuate, they've been doing these location drills. We had one yesterday. I don't think they'll do one to us today. If they do a location drill, we have to take the stairs and go down 5 flights. If it's an actual alarm, we take the stairs and go down all 25 flights, and we assemble in Cesar Chavez Park. You can follow one of us, and we'll take you there. So sorry to interject. Just want to make sure we did all of that.
Which means if you do that, you don't have to go to the gym tonight, right?
That's right. That's right.
Yeah.
And we have to take the elevator back up.
Oh. All right. Thanks, Ashley.
There's a real fire.
So, Bruce?
Yeah.
Okay, thanks. Our Administrative Services Officer needed an acronym for our time cards, so she came up with KBRAW, or KBRAW, which works well, and we've adopted that, so when we refer to this project, we use KBRAW, and it works well because we have significant wildfires, or we have catastrophic wildfires, or we have high-intensity wildfires, and there's been some debate over how we should characterize that, and that is a sensitive topic. But in any case, either one still works with KBRAW. So, Thomas, next slide. Just to go really quickly through this, we're here to get your comments, but We're here to review a procedure, a defined procedure to value or evaluate the greenhouse gas benefits from forest fuels treatments that hopefully affect wildfire or mitigate wildfire severity and size, and that could help flow money into forest fuel treatment projects for greenhouse gas offset benefits. And we will explore through the CAPCOA or the ACR or a variety of carbon offset exchange programs to work this protocol into them in the future. This procedure also will help hopefully flow money to forest fuels treatments from cap and trade auction revenues. It also could help forest fuel treatment projects when they're undergoing CEQA review to look at the greenhouse gas impacts of those projects. So an important next step will be to use the protocol in a case study on the Eldorado, and we've selected the Eldorado National Forest, American River, to look at an actual thinning example and work through the protocol and see how the results come out. We'll also get to looking at other benefits besides greenhouse gases. Water quality probably will be the focus, water quantity and quantity. And then we'll hopefully have a peer-reviewed technical paper, a case study report, a protocol, and a final report. Next slide, Thomas. So we kicked off this project about a year ago. We've established a scientific working group, a technical, which we're a part of those are joining today. We selected a case study area. We drafted a written protocol, which we provided to you guys a couple weeks back, and we provided a structure or a straw man about 3 months ago, and we'll talk more details today and get your comments. Next slide, Tom.
Bruce, this is Ed Murphy. I'm not sure whoever's doing the screen is sharing it. I haven't seen any slides. All I see is an opening slide or spatial performance group.
Well, Ed, you haven't missed anything, but thank you, and we'll get that going.
All right.
How about
there
now?
We go.
You got
it?
Oh, good.
I see it.
Okay.
What do you see? Do you see the schedule?
Yeah.
Okay. Good.
Thanks, Ed. So, next slide, Thomas. So today, again, we'll go through in as much detail as needed the protocol, but again, want your feedback and input and ideas on how we can tighten it up and improve it. Next slide, Thomas. And why don't you jump in, Thomas, to...
Absolutely. So
I'll finish with that where we can.
Okay. So we will get back to this at the very end of our conversation today, and we hope that we can get some written comments of everybody by late May, and then we'll have a second draft protocol based on these with these comments of you all integrated by June, and then start with the case study evaluation in Eldorado National Forest. For real this summer, and hopefully end this by fall, and then go to a release for public comment of the broader stakeholder group where we request feedback this summer, and then submit to a offset protocol registry fall, winter, and the peer-reviewed journal articles will come alongside with that in parallel.
Yes.
You may have, have you already started talking to any of the offset registries, or have any of those discussions happened?
We started talking with ACR in detail about this, and we'd like to start talking. Well, we started conversations with CAR, but we want to dig in deeper with both registries.
Okay, great.
Jessica Origo from ACR is actually part of the team.
Okay.
Yeah, and then we have reached out. So John Nickerson is familiar with what we're doing.
Okay.
He asked to continue the conversations with them.
Okay, I was just asking to make sure it can take a while. So.
Yeah, and we're not trying. We don't want to pick. The idea is
not pick one.
we want to. Well, we'd like them both to adopt it, but but we're not marketing for one over the other.
Okay, got it. Thank you.
So,
Bruce, you good? Okay.
More questions?
yeah, dig in.
So,
Well, actually, you know what? Let me take that back. Let me get some ground rules set up. This is not a presentation. This is going to be a conversation. A couple other things is that I know everyone in this room, most everyone in this room, has seen this framework before, right? So the idea here isn't to present the framework, but to start identifying issues that we found or we have to address within the framework, okay? Once we have those things identified, when we go, we have the next couple of weeks to figure out how we can dig into them and address them. That's the time where we want to start getting more of the meat pulled together. So your comments, constructive criticism is not only appreciated but demanded. Do not be shy. Please do not be shy. We have thick skins. You're not going to hurt anybody's feelings, right? We want to make this thing robust. We want to make this thing viable. So your input is really valuable. Okay. Start it, Steve.
question number one. So it's just the two registries you're trying to be consistent with? It doesn't include BCS or?
We haven't approached BCS.
We will.
But we
will integrate with the CAPCOA registry as well. Okay. Second question, which thinning project are you going to do the demonstration? Is it Pelican Thin or?
Thomas, it's connecting to Peter Stein's work with the restoration program. They had one in Klamath River, they had one in Eldorado.
Okay.
So Peter unfortunately retired.
Right.
So I don't know the answer.
Steve, we're going to tie in right now just because of our timelines to get this thing up and operational. We're going to tie into theoretical modeling with as much field data as we can get.
Well, but I bring it up because Pelican Thin and Cleveland Thin, which are both in the canyon, are going to be sold this year. So you can actually have some real live data if,
Nice.
yeah,
Okay.
and they're both excellent projects.
If we could take advantage of that, we will, but we don't want to limit our timeline to it,
Right.
You know what I mean? Because I know there's been other projects and programs which have tied into those things, and things go sideways.
Yeah.
We want to get this out.
Yeah, I understand. And then the last question, help my memory, but we decided not to take on renewables, biomass specifically, and
There is a section for biomass in here. We get to decide. That's a conversation that we can continue to add it or take it out.
This protocol will reference our biomass protocol. So it will have the allowance if the energy is electricity, you will have to work through all of the REC issues and all of the avoidance of double counting, but it will have that option. If the energy is on-site steam that directly avoids other on-site steam, then perfect.
Yeah.
Yep. And then, to complement that, it's part of the accounting framework that we actually have. So if you're willing to go through the additional complexities associated with the REC and those sorts of things,
You want to track the shipping and the trucking?
there's a placeholder for it. But if you don't want to, you could also take it out.
but that'll be part of the review with ACR and CAR as well?
Absolutely.
Okay.
As well as ourselves too. Right?
Well, yeah.
It will be in the case study.
Yeah. Oh,
Absolutely.
And I think that's the piece here. We have both. We have a full accounting framework that can account for bioenergy substitution, that even can account for product substitution. There are placeholders to plug that in. However, when you then look at specific protocols, they might be limited to some of these components and exclude actually potentially bioenergy. So you can then just take that out and account for it in another protocol, another scheme. So we are trying to be as inclusive as we can while also being protocol specific. Yeah, okay, cool. Jade, any questions? So just again a quick overview on the whole project. I'll go really quick through this because we want to focus today on the protocol itself. the project, the overall project goals and objectives are that we demonstrate and develop such a GHG protocol in California, and then the second objective is to demonstrate all the other ecological co-benefits and investment opportunities into these ecological co-benefits in a second step. So that's really the large picture item. Again, today the workshop is only about the protocol and how we can push that forward. Again, we have a broad support base here from funding partners and from stakeholders across the state and across private and public entities. We will have the study location where we basically test the protocol once more, starting with the groundwork and the modeling work. It has been started.
Steve, those projects are on that map. Those two projects you described. I think they are, Steve.
Oh yeah, they're definitely in the green.
They're in the green.
It's a big area.
We can definitely then pull at least from the treatment scenarios and prescriptions on getting input. Okay. So again, the case study will follow now the protocol development. We started already the data collection, and we will go into the data analysis and then modeling efforts this summer, starting basically next week. This lists again the 7 tasks that we have within this project. Right now we are task 3, looking at the framework, the protocol itself, followed then by protocol submittal later this summer, once we have feedback from everyone. And the other tasks are then more associated with the case study, as well as the avoided cost and return on investment analysis for co-benefits.
No, this is great. I mean, we talked about this stuff, so we can go through this real quick.
Timeline Bruce just mentioned before. So workshop objectives for today and deliverables is that we want to introduce all of you again the opportunity to ask questions about the protocol. We will go fairly quickly through every step of the accounting. We will try to keep time as much as we can. There are a couple of big picture items that we want to bring up. So that's really what we're trying to achieve today. The deliverable will be that we will take notes on all the comments that we will receive today. We'll work through these comments in the next 2 weeks, while we're also hoping that you have a chance in the next 2 weeks to look through the protocol itself and provide us with written feedback within the next 2 weeks. David?
Since there are a lot of folks engaged in this process, we're going to make an assumption. It's a pretty important assumption. And that is, if you do not comment, we're assuming that you agree. Okay? So no comment means approval.
Okay. So how we want to structure this conversation today, there are 10 accounting steps that we have specified in this protocol. And we would like to go through each of those 10 steps. There are some that we think are need more discussion than others, and we'll try to accommodate the time accordingly. But the overall, it should be a fairly high-level conversation that we are having today, just because of time constraints. So for each of these accounting steps, we would like to focus on 4 big issue items. So that's data availability, analytical capacity, level of effort, and tolerable uncertainty.
And the idea here, when we're looking at these general principles, is that we want this protocol to be able to be implemented by an intelligence group, not a cutting-edge research institute. It should be digestible enough and accessible enough for a project proponent who has an acceptable level of expertise to implement, right? So we don't want 1 or 2 companies in the entire country to be able to implement this. We want this to be able to be implemented by a wide variety of different organizations. So we have to keep that in mind when we're building and thinking what's different.
And you're thinking of private forest managers, federal, okay.
Yeah, exactly.
And what scale? I'm sorry, I don't know this, but what's the acreage scale that you're thinking?
That's step number 1. And you know, that's the first
Good
question.
timing, good timing.
There was another question on the phone.
Yeah.
Matt?
Yeah, so the other thing and I've been making comments in the methodology as I go along, the other thing that I think is really important to consider as you formulate this is the verification outfits, having the expertise, and there are certain aspects that I think you have to pretty clearly spell out so that the verifiers have something to hang their hat on as far as achieving a reasonable level of assurance.
It's a great point. That's a great point. We need to make sure the auditors know what to audit.
Yeah.
Yeah. The verifiers. Yeah.
Verifiers. Yeah. Okay.
Good point. Okay.
So acreage.
Real quick, just again, this is the overall undertaking, and this graph that we use to walk everyone through this whole exercise. It starts with a fireshed definition. It comes in with treatment definitions and how these treatments affect forest carbon, where it also ties into wood products and biomass. Again, this is the full accounting framework. Biomass energy right now for the protocol itself is a little bit a side issue, but can be plugged in, and the shadow effect of these treatments, direct, indirect emissions, basically.
Can you guys put yourself on mute if you're not talking? Thank you.
I think that person put us on hold.
They put you on hold.
Can we mute them at
If
all?
it happens, no.
Yeah, we can. We just
You can meet them.
Yeah, but then we're really sending anyone out. It works right now. Let's try this.
Okay.
So that followed in the end by a complex step-by-step approach how we can integrate different models from forest carbon modeling down to fire modeling, and then integrate all those into fire risk, hazard, and emissions accounting. I don't want to talk too much about this slide right now. It will come up as we walk through those steps. And those are the 10 steps that we structured the protocol after, and that we'll also have the discussion today in line with. So it's fireshed delineation, it's the management scenario, basically treatment design, followed by forest carbon calculations, all the growth and yield modeling, then the life cycle assessment for the bioenergy, for the biomass and bioenergy component. That's actually a separate task in the whole project. Weather data, then direct and indirect wildfire emissions, fire ignition, the whole thing around fire return interval, avoided redirection assessment, and then the integrated emissions accounting. So that's how we'll follow today through the conversation and how the protocol is written up.
We don't expect anybody to memorize the 10 steps. Yeah.
So what's the answer to Ashley's question?
We'll do that in the first.
Oh, we're not there.
So we have.
We're trying to get there.
Of those 10 steps, we have, I think, 4 focus areas today that might require a little bit more time. This is forest carbon pool, which pools to include, for example, a conversation around forest floor or dust, fire shadow effect calculations, then fire risk, meaning fire return intervals, integrated accounting. And that brings us actually to the first step with fire shape.
That tricky. That's the slide trick.
Yeah. Should be, where we can start the conversation now.
So with fire sheds, the way, do you have a slide that shows how we were thinking about fire sheds? All right, good.
Yeah.
So when you think about the way that we thought about, how do you quantify a fire shed? And I know several people in the room, Tadashi and a few of you other folks, have sat down and we tried to quantify, delineate what a fire shed actually looks like. And, they're difficult to actually put boundaries around because there's an ecological component, there's a social component, there's an economic component. There's all these components to defining what those boundaries look like. What's the size of the area that you need to manage? And so for this protocol, there's 2 general approaches we could take. One approach we could take is we allow the project proponent to identify what that area actually is, create some criteria around it. Another mechanism is to predefine the jurisdiction across the geography, and these are the fire sheds that you're actually operating within, right? And there's pros and cons to both of them, right? It's a trade-off, both of them. The pros that you see by creating those jurisdictions right off the bat is that for project proponents, that boundary is actually set. They know the area that they're operating in. We could cascade a lot of the other data sets that we need, or that the project proponent would need, into that defined geography. It could streamline a lot of the calculations. There are examples of this approach in, not that I want to bring up RED Plus programs, but jurisdictional RED Plus programs are taking root in a lot of countries, like Brazil, for example, is using that methodology quite a bit. The cons associated with it is that, as you all know around the table, blue screen of death on the screen, is that, you know, these issues are complex, right? It's, you know, a generic boundary is going to miss
It was 10,000 acres, if I'm not mistaken.
That was the size. Those are the projects that, based on the watershed that we were manipulating in our study here.
Okay, well, sort of building on what I think Steve was asking is that, let's say you've got 10,000 acres, that's sort of the minimum that you would want to have for implementation of the ultimate protocol. 10,000 acres may not, if you're talking about specific owners who are interested in implementing the protocol, 10,000 acres that you're dealing with may not coincide with fireshed boundaries, watershed boundaries, or whatever, and in a sense that doesn't matter, at least in my opinion. If you've got a contiguous area of 10,000 acres that could have multiple owners that are coming together to collaborate on implementation of the protocol, it wouldn't make any difference if it really follows watershed boundaries or whatever, because you're going to be able to still do the modeling and et cetera within the 10,000 acres, correct or not?
So from a technical point of view, you could do it. But I'm thinking about, what if you get into a situation where you have owners that aren't cooperating? So the idea is that you don't necessarily need, in order to implement the protocol, you shouldn't have, there should be a mechanism to allow a project proponent to implement the right sort of treatment,
sure,
without having to get everybody.
So you could have a 10,000 acre area that has 5 owners that are interested and 3 that aren't, and as long as you still have the information that you can build into the protocol for those 3 that aren't, you could still implement the protocol, because you're going to be able to show across the watershed what the fire reduction benefits are.
That's exactly it. So then if we could preload what those fire sheds, at what the size is in the meaning, I mean, it might be 5,000 acres, it might be 10,000 acres,
right,
it might be 50,000 acres. We have to find out what scale is viable.
Yeah,
right?
But again, so the term fire shed may in one sense be academic, because it's not necessarily a fire shed in sort of the generally accepted meaning of the term, not even watershed. I mean, it might not even be a sub-watershed per se, because it could go across a couple of different sub-watersheds, or, you know, whatever. The point is that you're going to have an area that you're going to calculate that has to be meaningful.
Exactly.
I don't know if that gets to what you were asking.
Well, but I'm biased. I'm biased on watershed boundaries.
Well, sure.
They're well known. That's a matter of, okay, we use 5th code, HUCs, or within 6th code.
No, so for a watershed boundary, right, if you have like the Sacramento River running through your watershed, I mean, that wouldn't work. You have a boundary.
Some of it depends, what we found in looking at these things, is some of it depends on a bit on what direction you're going. If you're starting from a perspective of, here's an area that we want to protect, we're going to design our treatments around the notion of protecting this defined area, then that leads you in one direction, sort of like a outside in. But the other way is, if you have areas that you're going to put fuel treatments, then you have to define your fire shed based on what the effect of those treatments is and how far out that goes, so like an inside out.
Yeah, I just think in terms of like trying to make this easy for other people to implement, I think that your first example would allow for the facilitation of creating data sets that allow people to adapt them into their methodology. in an easier way. And you're right. So maybe it's the fire shed. That term is probably not the right term. Fire shed study area treatment boundary. Have Bruce's team come up with an acronym for it.
I don't think necessarily need to come up with a new term. I think fire sheds define a spatial block of land that's contiguous for fire analysis. And to do that, it needs to be scaled commensurate to the target fire and the response to that fire, which is the suite of treatments that you're envisioning modeling. I think, it came out from the group that sort of organically came up with the term in the analysis approach was sort of at the district level, which is, this notion of 100,000 acres is sort of a good size because it allowed us to look at landscape scales and large fires, integrating across multiple pieces of ground that we might be treating. So it wasn't project specific, it was landscape. So I think the fundamental question here is one of scale, which is 10,000 acres big enough? Is 100,000 acres big enough? Clearly 50 isn't, right?
Am I right, though, that if the project proponent chooses a very small area, that is the most conservative or provides him the least benefits? So I'm almost thinking that the project proponent can choose 5 acres, and he can take credit for his wildfire modeling on those 5 acres. But his credits may not be that great. His impact may have been much greater. So I'm almost thinking that it doesn't really matter. If he wants to choose his fire shed as just the property he's protecting, but kind of in the big picture, conceptually, he again may not get the true value of that project. But
then you
so what?
But then you lose. I mean, you lose all kinds of things, right? So it's kind of like the person.
I'm just thinking about the amount of credits that will come from that project.
Yeah, and there may be none in that.
There may not be. It may be a negative, and there very well could be.
And I don't think it's going to be a target acre size that's ubiquitous across the state. I think it's going to vary depending on the fire behavior and the characteristics that you see across the state.
Probably, in reality, a certain minimum size is going to be economically feasible for anybody to even do the analysis.
Yeah.
Because, I mean, it already costs, what, $40,000, $50,000 just to do a TS. Yeah. So, yeah. So, adding this into it in terms of hiring somebody to do the analysis or whatever, I mean, you're not going to do it for a small.
You're not going to do it for 5 acres. So why don't we do this? So for our next step for fire shed, I think the thing that we need to do here, dig in here, is to identify maybe some potential sources where these boundaries are identified or that we could leverage.
I'd like to see, and as the protocol is written right now, it's just you justify what you've chosen based on some of these general concepts, which are very important. I would like to see, though, a default of the California Sierras. Here's some big default fire sheds that you could pick. If you want to do anything else, case by case, it would be allowed. And I think, again, it would be allowed because you can go as small as, I'm still not sure why as small as you want. It doesn't really matter.
Is there really a need to provide a default list given,
I'm not sure there is, Russ, but it may just be a good practice to have. I like your idea.
We want to make it easy. So, for example, we're able to create a shape file that says, okay, here's the starting place. Here's the starting place for fire sheds within this geography that you can get started with. Yeah, I think it would help facilitate the process. And here's the justification for those boundaries. And if you don't want to use those boundaries, use the principles that we identified to justify creating your own.
I suggest anybody sophisticated enough to try to do this is sophisticated enough to try to figure out what their appropriate area of analysis would be.
And you just made my life easy.
I think there's a lot of variables, the jurisdictional ownership piece, the scale of activity that's anticipated across the landscape, the geography,
the conflicts,
etc. So, obviously there is an economy of scale. You're not going to do your project. So, and clearly there may be a disincentive to go too big because that can potentially water things down, the potential effects you're going to have if the scale you set it up is much bigger than the level of actual activity that's going to be across the landscape. So there's a number of factors that are going to drive people towards making their decision as to what the appropriate scale is.
That's great. Any other comments on that?
I will suggest one for SMART, where the Upper American River project, I will write it so that will be one of the default that you can use.
Cool.
Cool. Yeah.
I might comment on just at least I think in concept, I'm not sure that the area or the analysis is going to be pulled up for the protocol.
Was that Ed?
Yeah. The last.
Okay.
Yeah, this is Ed. I just have one comment. I think. I mean, we're still early in the whole process here. I'm not sure the area or the analysis is going to be the holdup in terms of registries or ARB accepting the protocol. I think the permanence question is going to be the one that gets to you.
Give to us. You're part of this.
But to clarify, under the forestry protocol, we've already swallowed the 100-year permanence requirement. It seems to me that it would be very odd for the same regulatory body to move back to a 40 or shorter permanence when they've already approved 100 years. So I mean, I just think that might be a bigger hurdle.
Okay, so let's just move on. It seems like we have a couple ideas here, and it seems like this one's a minor one. So what is?
Yeah.
So that's the next issue. And again, if you do have comments, please document them in the doc that we send out to you guys and get it back to us next week or the week after.
So next conversations around treatment and treatment placement, treatment prescription, the first case within this fire shed. Again, these are the big picture items. We have something like 10 minutes to talk about treatment to stay on time. Again, data availability and logistical capacity, level of effort, sort of uncertainty is the big picture items. I guess there's always a question here with treatment around different ownerships within one fire shed, and how you can capture different incentives, different objectives of treatments across ownership when you do such a modeling exercise. Yeah.
This is not in your hard copy.
This is the treatments are part 2 of the.
Oh, you're talking about
this slide.
Oh, yeah.
He adjusted the slide. We adjusted our slide. So go to page 6.
Yeah, there was some adjustments. So treatment longevity is a piece here where it's just a feedback loop, I guess, where you run several treatments and check on longevity and which ones are in the end the most beneficial. There will be a back and forth. And in this context, David, anything?
So the idea here is when the treatments themselves, the things that we have to think about here when we're implementing this protocol, and where this thing gets tricky. Well, let's talk about where it's easy. It's easy in terms of identifying what treatments you're going to put on the ground and modeling them. That's not a big deal. It's also easy to identify, multiple treatments over whatever that time period is. So, Ed, if we wanted to use a 100-year permanent, there would have to be a bunch of maintenance treatments that would go back into that landscape as well. And getting those planned out in a way that maintain that efficacy graph that we talked about is important. That part's relatively easy and straightforward. What gets difficult, right, where we need to have some conversation, is how do we identify the business as usual, right? So the business as usual is a no treatment scenario, right? It's some sort of activity that occurs on the landscape. What is that activity? How do we make whatever that baseline is robust enough so we can model against it?
Well, and also, how do you bring in landowners with different levels of existing or, treatment? in a business as usual scenario.
Yeah, that's exactly it. And so some approaches there, some ideas there could be just taking historic treatment levels or historic activities on the ground at their current level and then just modeling that element forward and say, okay, this is what we're going to hold as our floor, and we'll continue that going forward.
And that would be project by project?
That could be, or fireshed by fireshed. Yeah, there's a question on the phone?
Yeah, this is Ed Murphy again. This is a personal pet peeve of mine, but business as usual is a bullshit statement. And so,
please don't hold back.
Well, I think we need to start changing this terminology, though, to be effective. And in the logic that you're talking about here, what it would be much better to say is no investment strategy. See, at least if a guy's going to go forward with a protocol and come up with a project, they're investing. They're actually taking a financial answer to the question at hand. So if you have business as usual gets completely confusing in my mind. If a person's out doing some sort of silviculture that has no intention to affect fire, then they're not investing. So if we change this terminology to make it clear that what you're doing here, you're investing in a way that's affecting fire behavior. Therefore, that's what is not business as usual, because who is investing in a business as usual scenario? I mean, so what I'm suggesting, it would be very useful for us to begin to affect this discussion by making it clear that the option between the project is investing versus the business as usual scenario would be the no investment scenario.
I'm okay with that.
Sounds good. Well, couldn't, all in favor? I mean, business as usual could include investments, but just a different suite of investments than what's proposed
I
with
would
the
call
treatments.
it a reference case. If you're
reference condition?
Yeah, reference condition, and that could mean, and that would include then the idea that you are managing your land, but you're not investing for fire protection. You're investing for some other end goal. So you don't have to call it business as usual, but there is some reference that you need a starting point, essentially.
But if I'm 30% of the fire shed, and I'm going to propose a project, 70% of the fire shed is national forest. Their baseline scenario, which is getting to Ed's point, is they remove 7% of annual growth on average. So is that the baseline for the whole fire shed?
It would be, so in this, depending on which approach we're using, right? So if our approach is to standardize those fire sheds, it'd be a weighted average between that 70% and your 30% would be the reference condition for that fire shed. Is one idea, is one way of dealing with it.
And the way it's called in the protocol is baseline.
Those are specific terms associated with the protocol.
But the baseline will include specific delineation of this area as a certain baseline, which could be treatments or some active, some management, some type. And then it could, the parts of the fire shed or the area, the baseline management will be different.
And you need to provide some images.
And then you rationalize that, exactly, Tom. You rationalize that based on current practices, previous practices, an evaluation of the economics of the thinning, right? I mean, these are established procedures in establishing the baseline.
John Nickerson, are you on the phone?
It's really no different. I mean, I hear what Ed's saying, but the baseline is no different in this protocol than IFM or any other force.
In the assumption
I totally agree. I'm just trying to get at the very useless and ill-defined term as business as usual.
Okay.
Yeah, no, we could come up with a better term, but the concept itself, I mean, I think we're in agreement on what, making sure that concept is implemented, and there's some complexity associated with it.
David, I just dialed in. I wasn't able to communicate through the computer, but I'm on here.
Yeah, no, the only thing I wanted you to chime in on is the business as usual term. Is there some sort of, is that like a term of art that we have to stick to, or can we migrate to another term?
Well, Ashley mentioned reference level. I think you need something like that. Ed and I had lots of discussions about that during the development of the forest protocol. My advice would be to standardize and keep it simple as much as you can. But I do think you need some sort of a reference level.
Yeah, definitely. We're on the same page, but there's nothing special. I mean, there's no special term of art associated with this as usual. It's okay to use reference level.
Sure.
Reference case.
Yeah.
Yeah.
The other term that's commonly used is common practice.
That's
see,
common.
The issue there is that, but that's where you would get into the question of how do you change common practice if you're going to change it to cause an effect on fire behavior by some specific aim treatment. You're investing a different level than common practice. So that's all I'm trying to get at. The business as usual is just a non sequitur. It doesn't mean anything in my interpretation.
Makes sense. And again, the business as usual comment here is not even replicated in the protocol. So I think
I'll take the blame for that one, Ned. I'll take the.
I think should we move on to the next step? Also, if we need,
I want to clarify that the fuel reduction by thinnings, shall we include both forest loss and thinnings in that definition, or are you just referring to the desirable diameter? I think we should include what's the slash, the forest slash.
All those different elements will be included.
Will be included?
They're included in the different the forest carbon pool.
I just want to clarify that when you say thinnings for fuel reduction, it includes the slash in the forest floor.
Yeah, definitely.
Okay.
Definitely. And the only complexity, well, there's two complexities here. One of them is the term of art for the reference condition. And the second one is how do we actually define what that reference condition actually is. And then we have some methodologies of doing it. That would, I think we need to spend a little bit of time outside of this meeting to actually dig into that.
And one last comment. I think the art of writing this protocol is that it's really generic enough to even allow for prescribed burns, and not just thinnings as a tool to do these treatments. But that's, I think, a longer conversation. So just to stick here with the time, I would suggest that we move on to the forest carbon accounting, which is one of the bigger topics that we earmarked at least for the conversation today. We have a bunch of carbon pools, forest-specific carbon pools that are included in this analysis and in previous studies that we are going on. Just a quick disclaimer: the wood products part are a separate project class in the whole effort here, but also in the accounting step. So let's not talk about this wood products issue right now. Let's focus on really what's happening in the forest and how we model these pools. I know that there was one conversation coming up early on during this protocol, how we actually work with forest floor and forest depth in general. If you want to include that, if you have to include it, again, this is a question, I guess, of the big picture items here: data availability, level of effort, the uncertainty associated with each pool. So I just want to make sure that we have some time to talk about these carbon pools that we want to include, and then find some at least way forward.
So you want to talk about now or wait?
Now.
Now.
Dig in. Dig in.
Well, you have to include the forest floor. It's the most vulnerable high component of wildfire emissions. You know, you've got many tens, if not hundreds of tons per acre in stands. You know, if you've got a forest floor that's 4 to 8 inches deep, there is an enormous carbon pool there susceptible to combustion. And if you do not address it, you've really, I think, missed a huge dynamic pool.
So right now, the way that the emissions are calculated, so there's two parts, right? There's the fire behavior. I'm just preaching to the choir with you. There's the fire behavior component, which is modeled using the Scott-Bergen or Anderson 13 fuel model. I don't mean to have my back to you. And so there's certain characteristics that allow us to model that part. And then when we get to emissions, we crosswalk those data sets with the FCCS fuel models, which have the forest floor fuels in them, and that's how we quantify what the emissions are. You know this firsthand as well. The data quality associated with that, I mean, that's the nicest way to say this. It's suspect. It's suspect. It's suspect at best. So the question is not whether or not is it important, whether or not is it useful. Going back to that list of principles, what's the accuracy? How much uncertainty are we willing to tolerate with that sort of thing? And Matt, you're on the phone right now. I know you've played around with some of this beforehand. Do you have any thoughts on this?
Yeah, well, I mean, I think when I was reading through the draft methodology, you have that it's an it's an integral component of estimating emissions differences, but it's not something that you track in terms of carbon stock change, other than its contribution to emissions. And I think that's probably the best approach, given the uncertainty associated with the size of that pool. I mean, you do have to absolutely have it in terms of emissions, because anything on the floor is where a good chunk of your emissions are coming from, regardless of fire severity. But I think the bigger question is, how is that forest floor component accounted for when you're simulating treatment? So, are you getting a reasonable reduction when you simulate, say, a prescribed burn in FVS, and that the emissions associated with that, and then if you do have a subsequent wildfire burn through the treated area in your simulation, you're seeing a reduced emission from that pool.
Yeah. So, yeah.
Does FIA measure it?
They're starting to.
Yeah. So there's one source, at least.
Here's the problem with the FIA stuff. Again, one of the concepts that we talked about earlier this morning was creating data sets that are easily accessible to a project proponent. Giving those FIA plots with that specific data that you can integrate with your project is not easily accessible.
You can't do it through FIDO?
No, because they swap and fuzzy. Okay. Yes?
John Nickerson. One comment I have is with regards to using this as an offset. I'm a little concerned about the ability to measure forest floor, dead down wood, and those sorts of things in a way that you can achieve a level of certainty that would be good enough for an offset. I don't know if you have some thoughts on that. And maybe this fits better into greenhouse gas reduction funds, but as an offset, we've had some problems in the past with lying dead wood.
Yeah, I mean, I hear what you're saying, John. So, I think in terms of orders of operation, let's pound through the methodology and figure out what that uncertainty is. And depending on where we land, we can just decide whether or not to go to offset or go after the fund, depending on how the thing gets pulled together.
Okay.
But one way of dealing with the uncertainty is to do the relative difference approach, which is it's a relative change. It's what we integrated in the existing methodology because we didn't know how else to deal with it. Kind of echoing of some of what Matt's comments are. Another thing that we could try to do or try to figure out is is there a way, or is there a system that's going to emerge within California, for example, that's going to have a better fuel cut characteristics, a better fuel model characteristic that tries to integrate those two together. I know there's a bunch of different research out there, and I know we're affiliated with some of them that look at the carbon stocking impacts to treatments over time. So we have some data sets over there, and we have a bunch of field data that's collected over there. But that's site-specific. There's nothing that's spatial in nature. In order to make this thing more easily accessible, maybe taking those sorts of data sets and combining it with some of these other standard data sets, like the land fire data sets or the land carbon data sets that are coming out soon, might be a way to reduce some of the uncertainty associated with the specific one.
So if you compare what we are trying to do here with an IFM project, you would have to have potentially an inventory effort anyway, starting the whole effort. So that's just this project. And if you then add a component in this inventory design that looks at forest floor, is it really forward?
That could be one, but that's an expensive one.
Yeah, I was just going to say, Thomas, the issue here is that you can't get anything that gets a statistically reliable answer out without a fortune being spent. way beyond what would be a sample inventory approach. That applies to below ground dead, below ground live. Standing dead quite often is in that boat, but above ground dead, down, and forest floor are all so variable that the sampling methodology would break you in terms of trying to get an accurate number.
Yeah, that's true. No, I mean, the IFM, you don't sample below ground live.
Of course. And that's not, I think.
There's somebody else trying to speak on the phone?
Another quick comment. One thing I think is if you could get to a level of scale where you could use FIA plots to derive your estimates, that might work.
Yeah. Well, I mean, the scale that I know that's where they become reliable is at like the county size scale.
Yeah.
And that's getting humongous.
This is Matt. Have you looked at the FCCS 30-meter res fuel beds?
Yeah. There's some uncertainty there, and the problem with the problem. I know, but the problem with that one is that Landfire isn't maintaining them. Like there's one time period where they skipped them.
Okay.
But that would have been a viable alternative because that's available across the entire country. They're tying that back in with the FIA data in a statistically, hopefully, robust way, and it's one less step for a project proponent to have to worry about.
Yeah, so it seems like you could actually have a couple of levels. One where there is some wall-to-wall coverage product that has some level of uncertainty associated with it, and then basically you take some sort of deduction given that amount of uncertainty. And the alternative is that the proponent could decide that they're going to go, sample surface fuels on some sort of grid and get a more refined estimate with lower uncertainty and use that.
Yeah, no, definitely. I know for one of the projects we did for ARB, what we did is we took that same layer that you're talking about, the FCCS layer, and we ended up modifying it based off of activity. So let's take the layer was vintage 2008, and we're trying to model things for 2012, and there were fires in 2010. We would modify the 2008 layer for those different characteristics to pull it forward. So that's one approach, and then the field-based data that you're talking about would be another one as well.
I think it's also important to consider fuel model success or fuel succession over time and the uncertainty associated with estimating fuels 40 years out or 80 years out or whatever under treated and untreated scenarios. And that's,
you're going to figure that out for us. No, that's true. So the fuel succession is also an issue as well.
I guess we're sort of dancing around the discussion of data reliability with regard to critical carbon pools that are associated with fire impacts. So, yeah. I mean, you can't do this protocol without numbers in those pools.
Right.
And we all know that there's relatively low reliability about most of those carbon pools. I guess how can you build a reliable protocol that you can then test based on, large regional data sets that have some remote sensing and sampling component, and then try to nest in some more detailed sampling to kind of do some validation of them. But again, I guess at the large picture, you're gonna have to populate those pools, or you can't do this protocol. Yeah. At least I don't see how.
No, you're right. I mean, that's exactly right. So, Thomas, go back to the previous layer. Let's talk about where these pools come from, right? Or the data for these pools come from. You see some of them over here. The above ground live, that's going to come in. When you forecast in the future, that's coming in from the FES using the modified algorithm, depending on which protocol we want to tie into. Field data, that's relatively straightforward and easy. Below ground is still the FIA data set along with the FES simulations. Wood products we're going to skip. Below ground dead is coming out of FES. Above ground live dead standing is FES as well. And then when you get down to those bottom ones, above ground dead down, forest floor, shrubs, and grasses, Those are coming in usually from the fuel FCCS data sets, right? Those wall-to-wall coverage ones, and or field estimates that modify those sorts of things. That make sense? So those are where the sources are coming from. There was SV as has components where you could actually model those out, but we didn't find them very reliable. We found that
This is Ed Murphy. It seems like at least the below ground dead as well as below ground live in this particular effort could be ignored because fire is not going to get at those. I mean, you know, I think, what's that?
Well, below ground dead gets consumed.
Yeah, come on. In what realistic percentage? You know, I mean, fire the
Ed, go look at the Valley Fire. There were, 80-year-old stumps scattered all over Boggs Mountain. They were completely consumed. It was actually a significant amount of below-ground dead consumption from that fire.
The portion that's available to the air burned, I'll guarantee you that 80 to 90% of the below-ground carbon did not burn. I mean, how did the forest soils of the world have 2.5 times the total carbon of the atmosphere if below-ground carbon was accessible to fire?
Well, I'm just saying that they're like, 4-foot holes of, 10-inch diameter old roots that are now gone.
And that's about 5% of the total below ground in that same tree. The bulk of it is outside that hole and never gets burned. So all I'm suggesting is, relative to this estimate, we should focus on the things that actually do go up in fire, like forest floor, and above ground standing dead, and above ground, on ground dead. But the stuff below the ground is extremely unlikely to be worth estimating, nor worth estimating an emission from, because the kind of fire it would take to do that is very, very, it's just not realistic.
So listen, anything that we could justify, anything that we could eliminate and justify eliminating it, I'm for. But let's just make sure that justification is robust. So let's mark, so when we do a review of these pools that we're going to be actually looking at, let's come up with a justification for each of them. Get your comments in as well.
Yeah, I actually agree with that. It's worth removing because you need oxygen to consume fuel. And you normally don't have oxygen below ground. But it does happen. It doesn't, you've made an assumption and you've missed some loss of carbon.
Yeah, so when we built this originally, and we're going to move on, when we built those carbon pools initially, we cast a broad net because it's easier to subtract than to add later on when you're in your accounting for us. So eliminating stuff if we need to is not a major issue.
And eliminating them would make your benefits more conservative, not the other way around, so that wouldn't be a problem in terms of calculating the benefits and, overestimating the benefits.
And I would second Matt's comment from earlier that you may need to do forest floor, and you can accept the uncertainty if you only count it as emission. Don't allow it to be counted as saved or counted in the offset side of the equation, because even in the best scenario, you're likely to get a ground fire that doesn't kill the overstory, but it's still going to consume a significant portion of that forest floor. So how you would ever credit the forest floor protection, I would think is, and that by doing it that way, you can accept a much more generic, general estimate for it, because it's not coming in on the accounting side as potential offset.
Yeah, and that's how we have it set up right now. And that's how it's, yeah. All right. If there's no more comments on the pools themselves, let's move on to the next one.
The next step is forest removal, life cycle assessment, anything that's related to bioenergy, biofuels, wood products. Again, this is a pool that we have in the end captured in a separate task. We are right now actually collecting data from several private sector timber companies here in California to get a little bit better data on what's happening in California, not relying on generic data from across the nation. So this is another contribution that we are trying to achieve here in this project.
So do we have, in terms of like us, we have data from Mendocino,
Redwood Company, and Humboldt.
Redwood Company, and SPI.
And we do have SPI. Okay. Good.
So this is the ongoing.
Go ahead.
Coming.
It's on its way. It's not there yet. It's coming.
June 1. We're being polite. June 1?
Yes.
So Ed, is it Ed?
Yes.
Ed, if I don't get it June 1, do you buy me a steak dinner?
Sure. I'll tell you a Trump steak.
We're recording this call, Ed.
But you didn't hear the rest. I said I'd get you a Trump steak.
Onwards.
That'll be filling, but not nutritious.
Just one more comment. We are trying to collect data here, not just on harvest scenarios and fossil fuel emissions during the harvest operation, but also get more customized data for California on the sawmill side. How much of these wood products or how much of the timber that's delivered to the mill is ending up in residuals, how much is ending up in various wood product streams with various lifetimes and decay rates. So this is another major push actually that we're trying to achieve with this project and contribute to general knowledge that goes beyond.
Okay. So, and again, a lot of this came out of the fact that some of the standard LCA protocols that were used generically across the nation were suspect for California, and we wanted to make it a lot more robust. That's why we spent the extra energy and effort on it.
Led by Ted Mason.
Led by TSS, our trusted partner in all things biomass.
So next step after forest carbon is modeled and the whole wood product LCA is figured out in this protocol is now getting into the details on fire modeling, and that starts with weather data collection. So this will be an interesting conversation.
So one of the hardest things to figure out when you're doing your fire simulations and your emission simulations are the climatic conditions for which you're modeling. And we just went through this collaboration with CAL FIRE and the California Public Utility Commission in terms of identifying statewide fire hazard threat utility index. What did we call it? What was that thing called? Fire threat utility.
Utility fire threat index.
Utility fire threat. So the underlying some of the underlying data sets that were used for it were 2-kilometer resolved climatic data at an hourly rate going back 30 years. So it's a very, very, very rich data set that should be publicly available and accessible. So that eliminates a huge chunk of processing that a typical project proponent would go for. So then the idea here, and this is what we did for the utility threat map, was to create percentiles for each of those 2-kilometer areas that are used for fire simulations. We could do something similar in this protocol and say, okay, depending on where your fire shed is, here's all the fire weather data in that area, and you model to the X percentile, 95th percentile, 98th percentile, extreme. And that could be one of the primary inputs for both the fire behavior side and the wildfire emissions component. That's one idea. The other idea is you allow the project proponents to develop their own fire weather data set and justify it based off of a variety of principles.
And recognize that fire weather's got 2 angles on it with regard to effects. There's basically the things that drive the fire behavior stuff, and then there's the fuel moisture stuff. Particularly important in this is the fuel moistures associated with the larger diameter material on the forest floor that really affect consumption. And it will take a little bit more data processing off the CPUC data set to get to the coarse woody debris, fuel moisture stuff. I'm working on trying to get that done through Desert Research Institute. I'm just having trouble trying to find a funding mechanism. Anybody that knows how to get state money over to Desert Research Institute, come see me, please.
Kenny, are you on the phone? Bill Kenny? Who? Oh, their thing started at 10. So there might be. So the choice really here, guys, is do we think it's worthwhile making these data sets processed and available and identifying the specific threshold that people model to, and that's going to vary across the state, right? Or do we think just allowing the project proponent to develop their own? And again, go ahead.
I think that this is Matt. I think you need to define whatever the threat, like the kind of the middle threshold is, and then also a lower and upper bound as a mechanism by which you can establish how uncertainty will be estimated for this particular parameter value.
Yeah, and within that sort of framework, all of the operational fire agencies, Forest Service and CAL FIRE, basically do some weather fire activity analyses such that they can sort of point to under what kinds of cumulative distribution levels do most of the fire acres burn. And then you could tier off of sort of an upper and a lower extreme confidence interval out of that. I think that you could write up some general protocols to mine that approach.
So would it be okay, Dave, would I'm volunteering you for some stuff?
Oh, I didn't want to.
Would it be okay if we worked with you to actually identify what those boundaries are across the state, building on the CPUC stuff?
Well, I think what I was getting at is that and it was mirrored in Matt's comment, is that if you go to Humboldt unit, the majority of acres that burn there may be in the 90th percentile, and if you go to San Diego, they may be in the, actually, maybe in the 95th percentile in Humboldt, and actually in the 90th in Orange County or something.
Plus or minus something.
But the plus or minus thing, that just seems like a good way of couching, the innate variability of the weather's influence on both footprint of fire and consumption. So
in terms of, like, again, trying to make this simple for the project proponent, it would be nice, and I'm a GIS geek, so I'm going to apologize for making everything spatial. If there was a raster layer that had those percentiles that varied across the state with a plus or minus associated with it. So, for example, a person could either just tap in to the CPUC data set and just extract out that component and use that, and or develop their own using those specific thresholds.
Yeah, I think that at least in a front-end approach, sort of, it will probably take some time to refine it. But that's, again, you got to populate that data set. You got to do it somehow in a streamlined fashion. Yeah. That seems like a very reasonable approach.
I don't think you can leave it to the project proponent alone to develop something, because there have to be some kind of guidelines that everybody can use. Because a project proponent in one area, there might be 2 or 3 that are in the same area that come up with different.
Yeah, my default is to create as many of these baseline data sets that somebody's going to need to use to get operational and allow them the flexibility to adjust them. The more of those we get built and operational, first cut, first whack version 0.5, right? I think it's doing us all a good service. And again, if we limit this to California, right, if we limit this protocol starting in California, a lot of those data sets and databases are available. Going back to the fire fuel succession thing, Tadashi, that you're bringing up, the project that we're doing with the CEC has a lot of those data sets collated. And so we could organize a lot of that stuff and make that part of this process as well. Okay. Are there any other comments on fuels, or not fuels, fire weather?
I'll make one comment.
Sure.
I think that an important consideration, we've talked about this before, but when it comes to weather, you have to make sure that your modeling efforts are consistent with the specifications of the treatments that you're designing. So if you're designing a treatment if you're modeling around a treatment that's designed to protect against the 90th or 95th percentile fire under 95th percentile weather conditions, and then you're modeling in these projects for like the worst possible case scenario, 99th percentile, then the treatments aren't going to work. So you have to make sure, I think, an important consideration.
Well, this will also define, I mean, that's an interesting thing. That's an interesting addition, because if we can create a map, because we're all going to do this together, that identifies what the standard size or what the target size fire weather probability is for a specific region, right? That will define what the treatment, how you're going to design your treatment. So, for example, if you're in an area that has fire weather extremes that are always at that 95th percentile, that's when all their fires are actually hitting, and you're designing fires at the 80th percentile, your treatments are worthless.
Right. I think what you're saying is, if you're going to model under X weather distribution, you ought to be building your treatments to that standard.
Exactly.
Otherwise, there's a disconnect.
And when we know that that area has fires coming in at that, whether that X percentile actually is, and we use that as the starting point for those treatment developments, you're giving a project proponent something to start with. So they could build their treatments for the 99th percentile, but for that specific area, they have to lock in at the 95th percentile, because that's when most of the problem fires actually occur. No, yeah, I'm getting mixed faces here, lots of mixed faces.
What you're talking about, as climate change hits us, you're going to get into the higher fire situations a lot more commonly than now.
Well, that's what's nice about starting off with a threshold map. So if you give them a threshold, let's say we start off with a threshold map, and we'll just make it generic. It's 90th percentile for the whole state. We know that with climate change, it's going to go up by 2%. We just add 2%. Not saying doing this. Some people make a more sophisticated version of it. But you add 2% to it, and all of a sudden we have a system that can start adapting to climate change. Are you following me?
Yeah, no, I just wanted to raise that if we're using historical weather data sets that we're going to use as a basis for analysis out over time for a 40 or 100-year project life, that's a problem, because we know that the weather's going to be changing.
Yeah, definitely.
I think that same token, probably coming up here pretty soon, is addressed in the question with regard to modeling expected fire frequencies.
I guess the alternative is to, well, if you're updating your analyses over time throughout the project life, then you would be updating your fire data absent some confidence in being able to project.
But then you get into a situation where you have like a private entity, right, going in and investing heavily in a specific treatment complex with set rules and set probabilities, with an expected return, not necessarily a financial return, but an ecosystem service return, and you're changing the game on them. Or Mother Nature's changing the game on them. How do you build that in?
So one way you could approach this, right, is that, I think I put a note in my comments that I'll send you, is that similar to some of the RED methodologies that are out there that require recalculating the baseline case every decade or whatever, you could have something similar to that, because if you, depending on the length of time over which you're looking at fire size distributions or whatever, I mean, that's influenced by the temporal depth of that data set, right? Yeah. And so if you're recalculating the baseline case and the project case, say, every decade, and you have a moving window of fire probabilities and weather, that's going to be accounted for. Those changes that are actually occurring in those data sets is going to be accounted for in that recalculation.
Yeah, it's like a floating baseline. And what's nice about doing that with treatments in general is that you have to do a reentry every 15 years anyway, 15, 20 years anyways, which could coincide with recalculation, or 30 years. But it's not going to be over the 100-year time period.
The fire percentile and reentry are both related to permanence.
Yeah.
Because the bottom line is that in a lot of the Sierras, if you design something for a 95th percentile, there's not any permanence guaranteed, because the percentile weather is, the worst case scenario is way higher than that now. And so you'd have a hard time justifying that you're your treatment is going to be permanent, even in some cases with reentry if it's only designed for 95th in a lot of areas. So yes, not every place is 95th. Maybe there are places that 90 is okay, but for a lot of the areas.
Well, recognize when you're talking about a cumulative distribution, you have the probabilities of the higher events. So it's weighted based on their probabilities. You know, they're intrinsically more rare. It is what I think is happening fundamentally in climate change is, if we've got this right, what is now a 99 percentile kind of occurrence in 50 years might be a 95th.
Oh, yeah, okay.
The likelihood of those, you know, that's what's really happening.
Yeah, that's interesting. Yeah, rather than
you're talking about just a stochastic
rather than the other way around. Yeah, yeah.
Yeah. So I think by creating that layer that we talked about, like, well, okay, what are the thresholds associated with specific geographies, allows us to adapt or move that threshold up over time. Right? It's like, okay, here's the bare minimum that you have to actually model a tool, unless you meet certain criteria. Okay.
I think somebody else just mentioned it, but any kind of protocol that allows for every decade changing the baseline and with some sort of increasing risk or whatever really makes it very, very difficult to find permanence, let alone what might be a reversal if the modeling changes the baseline above where you're at.
Yeah, but there is I was mentioning that, Ed, but there are, I mean, this isn't a new concept. So, like, if you go to, like Matt was talking about some of those, the RED protocols and even the jurisdictional RED protocols, they've addressed that issue head on, and they have some mechanisms for dealing with it. I'm more concerned about it changing that investment profile for a project proponent, making it less desirable, right? Because it adds a level of uncertainty that has to get factored into the overall, go no go on a project.
I think that comes also back in the end to protocol requirements for ACR. The permanence is 40 years right now.
The ACR is 40 years.
And right. if you want to stick to that protocol, you might need to have re-entries for your treatments to keep them up and fulfill permanence requirements. But not 100 years. So how do you want to deal with that? If you want to keep the long-term perspective in place here, I think that's definitely worth considering. But when we talk about a protocol-specific requirement, I'm not sure how to.
But that's exactly my point. So if I'm going to calculate an offset at the beginning of this process that relies on both future modeling and future investment, how do you give any kind of sense of permanence to that offset if future events have to occur to make sure that number's real? I mean, that's where I think the idea of this turning into a protocol gets very, very difficult.
Yeah, it's not. So you don't need to have a fire in order for it to be real. It's the incremental gains, and we'll get to it when we get to the wildfire, the probability of wildfire occurring. That's a huge conversation. I want to make sure we have enough time for it.
All right.
But then, yeah, let's move on. I think for the fire weather stuff, I think we have some talking points that we can move forward on. Yeah.
David, you mentioned RED a couple times. What is RED?
It's what is it?
Reduced emissions through deforestation and destruction or development.
No, degradation and deforestation. So it's a UN mechanism to stem greenhouse gas emissions from forests internationally. Yeah.
Right. Mostly targeted on developing countries.
Yeah.
It is. Okay. Yeah. Thank you.
Very nice. That and I feel better.
Well, you want to talk about Red Plus?
Over there. Yeah, no, this is Red supersize.
Should we take a short break or continue? Yeah.
Take a 2-minute bio break, 5-minute bio break. All right, 5-minute bio break. We'll reconvene at 10:35, so 3-minute bio break.
Instead of trying to find out what the actual number was there between the 7 and the 8, I thought you just kind of go, oh, I'm just going to make it short.
Not the
got into,
Well, you know,
the gas supply.
Yeah, I
on the
mean,
inside, but yeah, if you're out there, nobody's there. You're kind of screwed. You're kind of screwed.
Eric, we have not.
We have not.
Yeah,
Very nice to meet you. That was going to make you down there.
Oh, is that right?
Yeah.
It was going to be Sharon. It was going to
break off of G. I don't think they're owned by G.
Oh, thank you.
I'm glad that much of the
Oh, the sign.
They are still under their umbrella.
Okay. Really? Okay. So think of me as a nurse.
I did a Christmas card for over here.
He's better looking than I am. Our song is Vladimir.
Yeah, I know.
We have.
He got the whole spiel.
And I'm not.
Okay.
Yeah.
So
You don't want to. Sorry, are you working?
No.
I am working on this one.
This one, yeah.
Like Simi Valley, San Fernando Valley, a lot of new ones there. Things are joining in.
These are projects.
I was with,
it's really it's on the it's done well. So I kind of followed that a little bit. LA.
Right.
Okay. You know that Work Park or something else, Yoga Park?
We all talking.
Yeah. No, but yes, exactly. With the library. That's right. So, but the last other than just
No part.
but his last Christmas card was he didn't have
Guys were there, big contingent from the county came down. He's doing very, he hasn't let up. I get emails from him regularly about, what about this?
Not here today, actually. So passionate.
He's there. I'm just trying to get up to speed. It's bad analogy, but everyone understands that.
like the right straw
That's why fire season be my first rodeo. I'm filling my mind around how when we go into overdrive, when they happen, how to respond, how to respond. It's not it's what it is.
But you do have the 18.
Why do between Bruce and she was going to try and stop by.
Did he just send you that or?
Do we have her contract? You have her contract, but she has
I presume the Outlook meeting will have the web.
No learning curve there.
No.
The Outlook meeting has the web. We would have had the web link in it, right?
It should have.
Chris was on the phone, but he apparently was asking about
Does
he have trouble to call in? No, he called in. He wanted to get on the web. He was all on the phone.
So he didn't see the slide.
We had a back conference call this morning on how to
lost the link
on the file map.
But I have
the interconnection.
I don't know.
As I was reading the email, you have the contact info. And all I did was, what project was the actual meeting? I got looking in the lobby.
I don't know.
If there was the actual.
Yeah,
but I presume since that was the meeting that other people were going to use to get in, that it was there.
It is the same, but if you forwarded the original initial email.
No, I did. I forwarded it a second. They were both stacked side by side.
Okay.
Okay. No, I haven't.
Yeah. I just check. There's any category there.
Even your
Can you tell me?
Yeah. Well, I
know the people that use it.
We met with them. Yeah, something else. We talked about.
I know, right?
They have a study. They have a study going on, and they kind of let it back. That's all part of the
Pretty much. No. Anything on biomass?
Yeah. Well, I mean, I think we do
yeah, maybe like if you want to go with any of
Absolutely.
You know, I'm trying to understand like
I don't know, I can help you there. I know that it is. Infrastructure is made new. Also policy work. I'm just letting you know. Very clear. Guys, reconvene. I can help the order. How are you? All right.
Do you keep moving?
Yeah, let's keep moving. 5 minutes over my own deadline.
Okay.
We're all reconvened. So, Thomas, why don't we start in on the next item?
Direct wildfire emission. So we are at the 6th step, again, this is following the protocol structure. Direct wildfire emissions, we still have to talk about indirect and fire ignition probability, avoided redirection, and aggregated emissions accounting. I'm not sure how controversial or how much discussion we need around direct wildfire emissions calculations. Again, we are trying to stick to those 4 big picture items: data availability and physical capacity, level of effort, and certainty. We don't know. David, do we want to direct the conversation to any specific point? Again, I think the direct emission calculation could, from my perspective, could be pretty
yeah, the direct emission calculation. So when we talk about direct emissions, guys, we're talking about emissions within the footprint of a treated area. What are the emissions associated with that specific location? And the way that we're actually calculating it is we're using, again, we're trying to stick to stuff that's easily accessible and available to the project proponent. So we're using the standard models that are out there. Consume, FlamMap, Farsight, FFE, those sorts of things. The data sets that go into it include SCCS data sets or modified versions of the SCCS data set for the emissions. And we're also using the weather data set. That's the same weather data sets that we're using for the fire behavior model. So it's pretty straightforward. Again, we've talked a little bit about the uncertainty associated with some of the data sets that are out there. And we also talked about the fact that we're not quantifying the carbon stock. We're just looking at the relative change in emission, or we're quantifying the emissions from the fire in that specific geography. Well, are there any comments on this? Yeah.
Is direct discriminated from indirect based on it's just in the project footprint versus?
No. So direct is the whole fire shed burns.
Okay, the indirect stuff is emissions associated with stuff that wasn't a fire.
Perhaps we should just move on to indirect and we have to slide.
The indirect is the fire shed.
Should we do that?
Oh, well then.
That's different than what he said. So
and it's very different than what he said.
So the direct emissions are emissions associated in the treated area. The indirect.
But it's average. Geo summarized. It's average across the entire watershed.
It's average.
I mean the entire fire shed, including the treated area, right? And then the indirect.
I just pulled up the slide. Perhaps that helps. David, are you on it?
Yes. All right. So in the baseline scenario, you have a fire of size A, right? Assume that there's you have your reference condition, right? Not business as usual, but a reference condition where there's a fire, certain size associated with that fire, and there's emissions associated with it. In the alternative scenario, right, you put in a treatment, you put in a treatment in a specific location, and you quantify the emissions associated with that treatment, right? And you're doing this, we're showing just one example here, but you would be doing this multiple places across the whole fire shed. And then you have the fire still is larger than the treated area, right? It's going to be bigger, right? It's going to pay that, and you have a shadow effect where you have the emissions associated with B, and then when you compare that to the original fire size of A, there's a net benefit there. So what you're trying to quantify, three things. You're going to quantify the emissions associated with this, the emissions associated with it, and the size of this and the emissions associated with this. Once you have these two emissions and you know what that is, you subtract the two together, and the net benefit, right, if you want to look at the net benefit of emissions, is all the stuff inside of this. I'm sorry for you guys on the phone, you can't see what I'm doing.
I can try to follow you with mine.
The net avoided emissions, when you look at it, is there's additional emissions over here because this fire behavior is a little bit different than the fire behavior we have over here. But the net benefit is this whole shadowed area in this location. Okay.
Would you have termed all of the emissions under baseline in the pink area indirect? Because you've got an arrow going indirect in the fire side peak.
So that arrow is supposed to point to the pink and fire size B, right?
Yes. We can quantify this. We can quantify the size of this.
I see. It points to the hatched area outlining fire side A.
It's supposed to point to the B.
It's supposed to point to the B. It's supposed to point to here. We can't quantify this. We can quantify this. We can quantify in fire
graphics problem.
In the alternative graph, we'll try to be descriptive so people can follow me on that. In the alternative side, on the right side, we can quantify where it says RX. We can quantify what that area is because we know what that is. We can estimate what the size of the fire shadow actually is. You know, what's the potential area that's going to be avoided in emissions. That's this size. We can estimate what that size is. And then based on that size, we can quantify what this emission actually is.
We're just talking a graphics problem here because that arrow is pointing to the hash marks rather than to the pink.
So, within fire size A, how would you select RX and fire size B? Within that rectangle.
Those are modeling alpha.
Those are modeling.
Well, actually, RX is an input.
Yeah. RX is A, so you define where the treatments are actually located. That's what's identifying what this is. And the next slide actually describes how you actually quantify what that fire shadow is. Somebody on the phone wanted to talk?
Yeah, this is Matt. I think one of the problems here is that adding the direct versus indirect adds a level of complexity that's unnecessary, because really what you're talking about is modifying the area burned, or the area burned by a certain severity, right, and the emissions associated with that. So since you're basically summing the total emissions from a reduced fire size in the alternative, right, and subtracting that from fire size A in the baseline, and that's your benefit, do you really need to classify them as direct versus indirect?
The reason why we did it, Matt, is so when you're doing it on one specific treatment complex, in one specific configuration, we get to do it the way that you're talking about, but when you want to abstract it across the entire fire shed, and you're not sure where that fire is going to actually occur, and you want to create some sort of weighted emissions across the entire fire shed, you need to separate them out.
Okay, so I guess then that maybe it's just a labeling issue, because I think when one of the things, I had to read this twice with direct versus indirect, is in the literature, direct is the combustion emissions, and indirect would be subsequent decomposition, respiration, and the like post-fire.
Yeah. Okay. Let's change the labeling. Let's Thomas, we'll take that on. We'll come up with some new words.
I think a better way to think about it is the direct is really severity, it's related to the severity, change in severity, because you're not talking about spread of fire, you're just talking about the emissions associated, emissions reduction associated with the change in fire severity. The indirect emissions, as they're put on here, is related to fire size, like how big or small it is here.
That's right. And so the severity wouldn't necessarily, right.
But the RX is an input that you're modeling, and the fire size B is an output from the model, so you're kind of optimize.
You have to create model output. You have to estimate what that shadow area is, and there's a mechanism. We'll show you how that works.
But the RX is a user input. That's a treatment input.
Yeah. This is a treatment input. This is also the size. The change in size is an estimate.
Then you'll be trying to play with the model to optimize the input of the RX to get the maximum reduction.
Yeah, so you could use Tom or something like that to do that.
Will this, Matt just described indirect and direct as the literature reviews, will this system take account of the post-fire decay emissions from fire size A and fire size B?
We actually through the avoided redirection.
Yeah, I mean, we avoided,
no, only through avoided redirection.
Yeah, there's no, the decay thing's a really hard one to get at, just because there's not a lot of really great data there. And so we just we punted on that. But there is a section in terms of avoided redirection, type conversion, that we have built into here that doesn't really directly address what you're talking about, but there's a placeholder there. Yes. Bruce does, yes.
David, aren't the direct emissions, the treatment emissions, associated with the removal of biomass?
No. So there's the removal of biomass flows into the wood product LCA stuff. That's where that stuff's accounted for. You go back, again, it's clear that we have to change the terms here. So the direct emissions from what we were talking about, imagine having an area that you don't have treated. It's a thick dogwood, and you burn it up. There's a certain amount of emissions associated with it. You go in there, you do, when I came up with this term, you do some direct action. I go and I thin it all out, and then I burn it again. The fire severity is different. There's less emissions. So I want to capture that delta in emissions over there. The next thing that we want to capture is that, hey, when you put that treatment in, there's a shadowed area around that treatment. There's the area behind the treatment that's the real reason why you're putting treatment in. And the size of that area is going to change. It's going to be much smaller, right? And so what we want to do is we want to capture not necessarily the change in severity, but the emissions, the avoided emissions in terms of the change in size. So we know what the emissions were in the total size to begin with, and we know what the change in size actually is when we quantify these two elements, then we can quantify what the indirect benefit was from that treatment. I'm going to come up with a different term than indirect because it's clearly causing confusion. The shadowed emissions might be another way of thinking about this. But it's trying to break those two pieces up and quantify them. Now, the reason why we quantify them in two separate groups as opposed to putting them into one is the idea is that when you put this treatment complex out there, or a variety of treatment complexes out there, or you're trying to create a baseline scenario, you don't want to prescribe this for a project proponent up front. You wouldn't be able to say, here's what the general emissions are for a specific geography. Put in your treatment complex in a way that you think best optimizes your operations for whatever you're managing for conservation, timber production, carbon emissions, water utilization, whatever the blend is. And then that net benefit that you're going to capture is the average per acre size within that fire shed between the baseline and the alternative.
But John is right that the difference between the direct emissions from the baseline and the project is the wood products, or is what you removed, plus possibly a little more because the fire severity was altered.
Yes, but that's calculated, like I just said right now, Bruce, is that calculation, the wood product calculation, isn't taken care of in this step. That wood product calculation is taken care of in another step, of course. Okay, that's so. Yes. Yes.
So I assume on the wildfire, you take a shot at low, moderate, high severity.
Right now, we're just taking a shot at, and again, that's something that we could do. Right now, we're taking a shot at whatever that fire probability is, right? So it's the 95th probability. So you're picking, in a sense, what that severity actually is.
Yeah, okay. Because obviously it affects the amount of carbon that's actually released.
No, it definitely.
Well, that's all built in the baseline, or reference, or business as usual.
Sorry. Reference. I like reference conditions.
Okay.
So, like, if your reference condition is 95th percentile moderate, and you're looking at your additional benefits, you're also using the same percent.
Yeah.
And then you can do, and so the idea is, that's why we're going back to that weather conversation. Let's figure out a mechanism of locking down the bare minimum associated with it. That, either is a bare minimum associated with a specific period of time. If we're going to go with a 40-year outlook, it's going to look one way. If we're going to go with a 100-year outlook, it'll probably look a little bit different. And then move forward with that.
I'm also having trouble in mulling over on the post-fire. We should be measuring that decay rate for that stuff that's left on the landscape, because there's a benefit. You could have a benefit by removing that stuff and creating some wood products and storing that carbon, versus just leaving it out there to decay over 25 years and then having that methane component in the decay.
That's an additional complexity in terms of sort of an additional alternative was what you're talking about, because one alternative is sort of what's happening by default on a lot of national forest land, is a lot of it's just left out there because of controversy,
right?
Versus private land where they go in and fairly aggressively salvage that material. So
that's a new protocol or an offset of the biomass or wood products protocol.
Okay.
When the fire occurs. Right. This is all conceptually. This is all.
It would be
theoretical in a sense.
It would be a sub calculation to this.
Yeah.
It's another potential element that could be added to this, but it's different.
Yeah. It is, and I think it's an important thing, but an important element to add, because if you're not accounting for, accounting for avoided conversion as well is important, but if you're not accounting for, in the baseline scenario, a wildfire that, let's say, kills 80% of the stands, 80% of the standing above ground carbon is now dead. So this base case, your wildfire is putting all of that into necromass, and over time is decaying. That's really what you're trying to reduce or avoid, right? So accounting for that is important, but also
like you said, that it's a level of complexity because like the offsets are going to be calculated for a specific year, and the benefit associated with that decaying biomass depends on when the fire was in relation to when you're trying to get credit for, Yeah.
But we don't have, listen, the decay data we don't have. We're missing that.
Really?
I completely agree with what was just said, and it's a little harsh that we have to account for the decay of the wood products we pull from the forest, but we can't right now account for the decay of what we don't take from the forest.
Yeah. True. But it is different in the sense that this protocol is looking at emissions from the wildfire, not the post situation. So, well, I understand, but I mean, I'm not saying it's not important, but I'm just saying that it's a different level. It's sort of an offshoot box down here that we haven't talked about really up to now.
When we started looking into this, remember this? It was trying to get the data sets.
I know.
We're trying to get the data sets to make this thing robust and viable. Steve was.
I understand.
That was.
This is a big one.
But what he's talking about is really important. Because,
yeah, no, I know.
Because we have so much controversy around post-fire treatments that this is an element that could really help solve some of that discussion in terms of what's happening out there and what the effects are over time. And
and then there's another box. There's the post-fire decay box, and then you alluded to it, then you have the type conversion box.
We have the type conversion box. We got that one.
Well, then, if you got the type conversion box, how did you account for the carbon that decayed before you got to the type conversion?
Well,
or during the
type conversion can occur whether or not you do any salvage.
Yeah.
I mean, you can do nothing or salvage and still have the same result, right? I think that seems to me, but yeah.
I give.
We need to build the.
No. You brought up a really important point.
So let's write that down as a potential thing to look at.
I think the decay rates exist. Good enough.
They're
not perfect.
I think it's also important because I think if we're not salvaging the dead material, there's a leakage effect, and somewhere else they're harvesting live sequestering material in its place.
Yeah, that's a good point. Matt, did you find the data?
No, I was going to just chime in that the literature is pretty scarce on decomposition rates. There's that one paper, Mark Harmon was the lead author from the Southern Sierra, dating to like 1986 or something like that.
Yeah.
But then the other thing is, I was thinking in the reference condition case, are you you basically simulate a wildfire occurring in an untreated stand and then grow that forward, right? Because you have these regeneration. I mean, that's the next topic, right? Is talking about regen.
Yeah.
And so FVS inherent in there, the stuff killed by fire will there's a decay rate for that, right? And so that loss in carbon stock is actually reflected as that increase in dead material declines over time in FVS. It's actually, in terms of total ecosystem carbon, is represented in those FVS outputs.
But it's yeah. So how believable are they?
Well, you're talking about a stock change, right?
Yeah.
And so you're not actually saying what fraction of that fire-killed material ends up in the soil versus the atmosphere, right? So it's not accounting for the partitioning of that flux, but it is because at the core of your equations here is really and all these offset protocols is a stock change methodology, right?
Right.
And so if you have a particular stand that burns under with a 80 or 100% mortality, all that stuff that's killed, assuming it's left on the site, your total carbon stock decreases over some period of time within the model, and then so your stock change, TN at TN minus 1 would account for that. It's just not saying that it's ending up in where it's ending up.
That's true. So I've never felt comfortable saying that we've included decay in this protocol, just because I don't.
And we don't look at tree mortality.
Yeah.
We're not looking at tree mortality.
No. Okay.
I don't think the data are sufficient in order to do even a Sierra-wide estimate of what the indirect emissions post-fire are.
That's what I've been saying all along. Okay, good.
So one additional box.
Nope, stop adding boxes.
Well, no, but, and I don't know where this fits, but the comment about leakage.
Yeah.
Brings to mind, hypothetically, you would have leakage because you're going to green, but in fact what's happening now is there is no leakage because there's so much dead material being produced that the green sales aren't selling. And what's happening is that that's actually increasing or decreasing the amount of acres that are being treated green-wise, and is increasing the amount of area that's susceptible to wildfire by default. So I don't know how all that fits in here, but it's an additional complexity that intellectually it's interesting to discuss it, but I have no idea how in the hell you account for it.
So that's being integrated. That would be I can't talk. That's getting integrated into the reference condition, right? So people are changing their behavior.
Well, theoretically, but I don't know if it is actually going to be built in, is it?
So the argument as it's in the protocol right now, because this is a must-have component for all of these protocols. The argument that we have in there right now is that the expectation is that we actually get more wood products out of the project than under the baseline, because we do treatment, and these treatments produce the products that would not have come out of the forest otherwise. So the leakage, we argue, is in the end a non-issue.
Well,
that's how the argument goes right now.
Yeah, well, I'm thinking that it's a non-issue for two reasons, but I think one of the reasons is negative, and the others might be. Sorry, I didn't mean to bring that up. It's a sad situation that we're in.
Shadow effect.
I have another emissions issue I wanted to raise, and looking that you're treating particulate matter and our old friend black carbon as being optional, and I just kind of want to raise that as being an important point. We know that wildland fire in the state is the largest source of black carbon emissions, so I'm just wondering why you're looking at that as optional rather than something you want to have hardwired in there.
So that is actually an addition that we built in just in the last month to even mention it. The black carbon accounting for protocols, for offset protocols, is still a fairly uncharted territory. There are new protocols just coming up now that are driven by cook stove emission savings, and so there is some data available on just converting in the end black carbon into global warming impact. I think it's fairly usable. So this is a new hook that we're building in here right now, and that's why I label it right now optional. But yeah, open for conversation for sure.
And that's something, excuse me, that FCAT is getting responsibility for. The forest carbon plan, the short-lived climate pollutant plan is pretty much done, and they're saying forest carbon plan, FCAT, we're expecting to take responsibility for dealing with black carbon, so from wildfire emissions. So
it could switch later to being included. Like right now, if you look at the rest of that list, there's a lot of things we got to pound through.
Yep.
So there's at least the 2008 study that was done in Northern California by ARB. I don't know if there's others, but there's at least that
look at wildfire black carbon.
Black carbon.
Oh.
Yeah. It was a respiratory study. You know, we exceeded
the public health one.
Yeah.
Yeah. We can incorporate it. I mean, that's why it's an optional thing. There's a placeholder for it. But there's, guys, honestly, there are some major issues that we need to deal with before I think we get to black carbon.
But I do think Russ is right to keep it in as a placeholder for later, because it will be it's an important part of the state strategy at this point. So.
Yeah, and I think it's there. I mean, we could change it later on. I mean, if you want to, we could use a different word than optional. Maybe phase 2.
Yeah.
And same for decay. 5% per year would be a good place to start, and use it until somebody proves it wrong.
That's the way it works.
That's kind of what the Harmon. Harmon was around 5%.
Does your models do mortality? I mean, can they estimate or project?
We just use FBS.
As Matt was saying, FBS will estimate. I mean, estimates fire mortality.
That could come right out of it, and we could just use Steve's 5% a year or 2% or whatever.
I don't know what they should.
You're diving off the bridge in terms of reliability. There are zero models with any reliability for mortality.
They're big wags.
There are regional specific decay rates that are used by the FASM model, FASM GHG model for softwoods and for hardwoods. There was a fairly recent paper from Woodall that generates decay rates based on precipitation and temperature. The problem is that it's very different for standing biomass snacks versus down. Then it's very different for snacks that are actually burnt on the outside. They can last for 150 years. I got actually pictures from 1870 with snacks on it. And then the same picture taken just 10 years ago, same snack still there. And it's not a big one, that size. So it's really...
That was 10 inches for those of you on the phone.
It's also species specific.
Yeah, that's what the rule says. So you're... It's tough.
Any other...
I think we need to recognize that we know we can quantify very well the emissions associated with the treatments and their impacts, but because we're not doing the decay post-fire, we're not doing the black carbon, or at least not initially, the treatments are already fighting with one hand tied behind their back.
Yeah. Are there any other comments, or can we move on to the shadow effect? Can we talk about this one?
Yeah, I think I don't know how much we captured already, sorry, by talking about in the end the indirect emissions. I pulled this up here again to have the conversation direct versus indirect. So I think, I don't know, are we good?
So the shadow effect, guys, is basically trying to quantify the area that the treatments actually impact. You know, what's the reduction in size and severity of fire due to the treatment installation. And the way that we actually do that one, do you have a slide on that? Is basically a Monte Carlo-esque simulation. It is a Monte Carlo simulation where you put in your treatment complex, or you take your landscape, your fire shed, you randomly ignite a certain number of fires. Does this sound familiar, Dave? Over a certain period of time, and I think we had a 24-hour period, or I forgot the time period, but we had to prescribe what that actually is, and we get an average fire size for that, right? And then what we do is we put in the treatment complex themselves, we recreate the situation, and then what we do is we get a percent change, an average percent change in fire as it relates to the acres actually treated. And it gives you a general index of that specific treatment complex across that entire landscape. That's it in a nutshell, yeah.
Were you planning to use Flam Map or Grid Fire to do that?
Flam. We want to use Flam Map. We want to use easily accessible stuff. Grid Fire.
Oh, right.
Yeah. Now, if we needed to assess this whole thing for the entire state to come up with some standards and norms, if we needed to do that, we would use
computational efficiency. You'd go to
we'd go to Grid Fire.
Is Grid Fire better?
Faster, for sure.
Oh, so we're doing the more comprehensive list. Grid Fire is actually easier, or doesn't take as much effort.
It takes a lot of effort.
Oh, well, I didn't understand that.
No, so it's faster in terms of so Grid Fire we computed as that. Speed and accuracy don't necessarily go. That's not the same thing.
Monte Carlo fire simulations are really computationally intensive.
You're not going to waste your time and not get an answer.
So let me just word it out. So if you look at SlamMap is a Windows-based application that runs on your machine with a certain number of cores, like 8 cores, 16 cores, and it's good. It runs in simulations. GridFire is built to run on this clustered environment where you're using hundreds of cores, where you could run 120 million simulations over a projected period of time for the entire state in 3 or 4 days. You couldn't do that on the PC. It's just not computationally possible. It's the calculations, the equations, the underlying science is exactly the same between the two. The tools themselves are built for 2 different computational infrastructures. That's the only difference. And so in order,
the same math.
Same math. It's just the computational infrastructure is different.
Never mind.
And so then the question comes up, this goes back to what we talked about beforehand. If we want to create some sort of efficiencies for a project proponent, we could suggest that, hey, listen, use SlamMap or SlamMap type of equation with a certain number of simulations based off of the acres and some parameters around that for a certain period of time using certain weather conditions for your alternative, right? And estimate what the size is, and we'll give you the reference scenario because we could preload that. Or we could have the project proponent develop that themselves, right? Now the general approach, the underlying methodology is basically looking at the change in fire size between the alternative and the reference. And I think this methodology, that the Monte Carlo approach, is the most digestible way of doing it, unless somebody has an alternative. The real question for me here is how do you scale it so it's easy for other folks to do it?
Well, you're also capturing. I don't know. You're not doing the course. You're not doing the emission side of this in the SlamMap.
No. So the idea here is just to figure out the reduction in size.
I thought the key to this, Dave, was how long you let the fires burn. If you do 5 hours or 2 hours or 24 hours, I thought that was the key to determining how well your project moderated the fire behavior. Is that not true?
There's a couple things, right? So the time, that's another thing. So we want the fire to run through a full cycle, right? Like from 1 p.m. to 1 p.m. We can do that. It just requires a lot more computational time. It's a lot harder to quantify.
Would the result, if you ran it for a 5-hour and then ran your 1,000 for the baseline, 1,000 for your project, if you did a 5-hour simulation, then I did a 10-hour simulation, would I get different shadow effects?
The percentages, I'm guessing, I don't know the answer to this, but I'm guessing would be similar. The percent change.
That's something we should probably.
The percent change should be relatively similar to each other. No? Yeah? What do you think?
I think so. I think the only thing that could wrinkle that would be the spatial in the school network.
Yeah, I mean, like, so for example, you put your treatment in a place, if you put your treatments in a place that has high fire hazard severity, and you let it run, and that area that's outside of it is all bare rock, right? And you let it run for 1 hour or 1,000 hours, it's not going to change. But if you're lining it up where you have some really flashy stuff on the outside, like shrubs, it's gonna. That's what you're getting to. But then that's where the Monte Carlo jumps in because theoretically you're balancing all that out. But that's something that we should probably investigate. Is there a threshold associated with that?
Yeah, and I think the methodology should actually specify both the number of ignitions and also the burn period.
Yeah, I do. I mean, I think the number of ignitions should be a function of the size, right?
Yeah.
So if you're in a fire, it's like a number per acre. So you should have whatever.
Although right now we think that the burn period is somewhat dependent on fuel type, fuel loading, and the weather conditions that you're inputting into the system. So I mean, for like say a 240-minute burn period, you may get a fire that's going to burn your whole fire shed, or you might get something small. So. Some of it is variable. I'm not sure that you could necessarily specify a specific burn period, but you could specify maybe a range.
Yeah.
Well, that's one of the interesting things that we've got to investigate with the PUC fire climatology data. The typical durations, because we've got hourly data, you know, sequentially, so we can actually see how long these relatively significant episodes are. Because that really actually ends up being really important in large fire.
Yeah, we're lucky to have that. So like a lot of the questions that are being asked right now, a year ago we couldn't answer them. Now we have the data to do it.
A couple of questions.
Dig in.
And I don't know if this is relevant, but
you can add another box.
This is a question in terms of implementation of this protocol as we see it. Yeah. So let's say that we've got a 100,000 acre watershed, but we're focusing on, let's say, a 10,000 acre subwatershed. Okay, and you've got a couple owners, and let's say that this is my hypothesis is that we ought to be moving toward treating more like 70% of the landscape. So let's say that we...
Is that 7-0?
7-0, yes. Versus the like 25% that the Forest Service is doing on national forest lands now or less. But so let's say that they come up with a plan to treat 7,000 acres in the 10,000 acre subwatershed. And when you do the shadow calculations, the shadow goes well outside the 10,000 acre subwatershed. I'm assuming that you could still take credit for the reduction.
I would argue yes.
Okay.
Well, I think you have to have a buffer around the treated area large enough to capture the footprint of the largest fire that grows, either outwardly or inwardly.
Yeah, okay. So then the second question is, and I hadn't thought about this previously, but let's say 5 years later, they go in and they treat a lot of the area that's the shadow of the first calculations.
We never define the shadows. It's just...
Well, you don't define it, but you're taking credit for it.
You have to do like a discounted credit for the area that was previously treated.
I mean, you would look at this new area separately in terms of what the direct and, well, what we'd not call it direct and indirect, but the direct and indirect of the second go around.
Yeah.
Which might overlap and might not. So again, it would be not necessarily discounted, but in some cases it might be. But how would that affect the first area? All it's doing is increasing the permanence of the first area, I guess, in one sense, right?
Yeah. I mean,
I think just given how stringent the protocols are, you'd have to come up with some discount rate that says because the area was already treated and, you know, we calculated that it had an effective date of 15 years, we only take credit for, you know, shadow effect on X number of years or something like that.
Well, you would have a whole different shadow potentially from the second area anyway.
That's right.
So
and it would expand.
Yeah,
you might get actually more credit.
Well,
the way the framework, the way the calculations in the accounting set up, that stuff, you can put them in at a different time period and it will all integrate. So that's still in there. And then the discount factor that you're talking about, Bruce made some additions where you actually you're taking credit. You don't need a fire to actually occur in order for the credit to actually be realized. It's the probability of fire occurring over time.
Sure.
And when you do put in a treatment complex, let's say you have the first one in year 0, and you put the next one in year 15, and it's in that shadowed area or referenced around that shadowed area, the probabilities and the way that they're actually set up would integrate together because they're operating within the same landscape. And that's one of the reasons why we decouple a lot of the calculations, so you're able to build little Lego cities with them.
Yeah. Well, it wouldn't have to even be in the shadow area. It could just be that the shadow area from the second area overlaps with the shadow area in the first area. Well, there would be a discount.
That's the treatment design, though. That's good treatment.
Yeah. Okay.
Right. So I know we're running short on time, but I wanted to make one point about the indirect emissions assessment, and I think it's an important one because the change in fire size in that modeling framework is largely dependent on changes to fuel structure, fuel loading and fuel structure, which is dependent on what comes out of the forest growth and yield models. So the change in fire size, the fuel succession, the change in fire size, whether it's believable or not, depends on how believable you think the model is in predicting fuel models 40 years from now,
we're not
years from now, or 20 years from now?
But we're not using FBS for the fuel models, right?
Yeah, because FBS is where at least that's what I was doing in the past was the FBS, the fire and fuels extension of FBS is estimating fuel loadings and slotting those fuel loadings into one of the stylized fuel models, 53 stylized fuel models.
Right, and then we get this up with what robots created, we do the crosswalk.
But that's for the emissions. I'm talking about for the size, our size, which is this, you know, in FLAMX specifically, whether or not you get a reduction in fire size depends on how your fuel models change over time. So, and FES in particular, you know, it's like Brandon Collins has been working, I think, on looking at, and you guys in that CEC project were looking at, Venkatesh, I think, was looking at the fuel model succession and whether or not in the Sierra it was overestimating or underestimating fire spread. So
well, that's one of the key. There's a couple of things that are coming out of this meeting. One of the key data sets that we need to incorporate or get built into this whole thing is that fuel succession work that we've been working on, that we've all been working on in a variety of different areas. We need to bring that. We need to organize that and bring that into this conversation in some sort of digestible way, along with the fuel flare stuff. Yeah.
And you probably ought to talk to the land fire team that has been working on the, you know, update process to disturbance. You know, there is a body of information that's flowing into a central location trying to document fuel dynamics. And it's a tricky thing, but if FFE is giving you what the fuel model is at X time when that fire burns, your size is, you know, your net footprint of what I think is indirect.
We'll come up with better
ends up being a function of that logic call that comes out of the fire and fuel extension. And neither Brandon nor I have a huge amount of confidence.
And if the concern is really more about long-term effects here, I think one critical part coming at this again from the protocol point of view is that we incorporate here that there are monitoring requirements throughout this project, and if you need to update this baseline over a certain period of time with new data, with new weather data that's available, with new modeling approaches, I think that's it's not unusual to have that built into the protocol.
Yeah, I mean, calibrating the model is a fundamental part of the process, right? So I was saying, like, you know, calibrate it to the current fuels, and you can update it over time as you're working.
Yeah. So I don't know how much more time we need on this. We still need to talk through 3 different steps. Ignition, avoided redirection, and the aggregated accounting. Should we just move on to our return interval?
Yeah. This is a fun one.
This is a fun one. So again, to talk about fire return intervals, we had, this is a slide from the previous Plaza study from 2000.
Dave, do you know what I'm going to say?
I know you're going
to say. Sorry.
In 15 seconds, I really, really, really wish you would not call expected burn frequency or burn probability fire risk. Quantitative risk has a very large history behind it, and it nominally is expected value change or damage.
It's my fault. Don't forget, it's my fault.
And maybe you might want to call it a fire chance, because that's easy and it captures the notion, but it gets rid of that term risk, which is an impact of fire, not the likelihood of the fire. Okay, I'm off my soapbox.
Yeah. So a way to deal with this in a historic context, in a current context, future expected return interval. The impact, I'm just going now pretty quickly through the slides, so in the end, through these slides, to end up, I guess, with this. We have identified 4 different ways.
Go back to the previous slide and explain that one.
You want to use this one?
Explain it, yeah.
So this is, in the end, 2 snapshots here. The upper left side is periodic chance of a fire hitting by year. So you see that when you look at the red line, it's for 15-year fire return interval. You have increased chances of this fire. It's basically annual probability for the fire hitting a certain spot. And then at the right-hand side, you have the accumulated effect, basically all these annual chances, annual probabilities added up over time. And for the 15-year return interval, you basically reached, let's say, 90% fire risk of 90%. So fire chance. Risk is what you can quantify, right? In this point, you are a quantification. So it's in the range of 30. That's actually the definition of risk.
What's the treatment type, the time since treatment? Does it matter? Sort of agnostic?
Yeah, that's basically just when you start with your. That's probably not a very good description.
So you can think about if you put multiple treatments in place, you're going to have multiple distributions. They start getting ready together.
Yeah.
And then what you're looking for is those incremental gains, right? So going back to your discount factor, this is one of the ways you discount potential emission savings over time. And then if you look at the big thing to look at here, it's easier to see on the graph on the left, is that, again, with a shorter time period, you realize a lot more of the benefits if it's a shorter time period, right? In a longer time period, you realize less of it. And the question is, it's like, well, there's a variety of different ways for picking these sorts of things. Which method do we want to actually use? And if you go back, Thomas, why don't you go back to the way it's doing it?
Which one?
This one right here. So if you look at the three, there's three ideas. One of them is to go back to like some sort of restored state, right? Like putting in a restored fire regime, like a pre-settlement condition, 15 years, 20 years, 30 years, whatever that is, or identifying how it's going to vary across the state. That might be one approach. Another one is using, well, what is the existing current return interval on average across the state? And then you get into something that's really, really huge, like 200 years. And then there might be something in between where it's like, okay, where's the desired condition? Where do we really want to be? What do we want to manage towards? And that could be someplace in the middle. But that's, part of this conversation is science, but the other part is going to be policy.
Well, I think your first one, the restored one, that's where, in policy, we're having a lot of discussions about not restoring to an existing condition, and so like striking that as where you would go.
But the curve's pretty.
Yeah.
Well, I think the question in terms of an offset protocol is the real and verifiable, the real, what do you question, right? Like, what do you actually, if I'm standing on this piece of ground that I treated, 20 years from, 10 years from treatment, what is the probability, not, previously, but what is the probability at that moment that of the fire actually impacting that? And so, I think looking at the contemporary record, but also considering localized spatial changes, based on, you can look at the contemporary rotation in your particular type and region, but also considering the spatial surroundings. I mean, we know population density and distance to roads and those types of things are huge factors in the likelihood of fire impact.
Yeah, I feel like, so if we wanted to go down that, and I'm okay with whatever angle we want to go, but if we want to go after the contemporary route, then that also, if you look at that return interval, that incorporates suppression as well, right?
Right, but that 200-year number,
that's just illustrative. It's not
exactly, yeah. But so, like in, let's say, mixed conifer in the Sierras, if you look at the fire rotation in the last 10 or 15 years, it's not 200 years. It's shorter. If you just look at the.
So we've got some actual, numerical analysis based on fire history records that are showing some upward trends, despite increasing expenditures in fire suppression. So there's a signal showing itself.
What are you saying by upward trend? Length of time, or
reduction in mean fire return area.
Okay,
so an increase in burn probability.
Okay.
And these are supported by modeling techniques like Leroy Westerling has put together using his, statistically based model that is inferring the influence of climate change on these trends. And Matt can probably comment better about the actual, quantification of those estimates coming out. But, the data and the analysis suggests that fire in coniferous forests, where I think most of these protocols would be applied, is increasing.
Is there something you guys are currently using that we could slot into this position, into this box?
We're talking about it for some of the greenhouse gas reduction fund projects. With different methodologies. Because one of the difficulties has been leaving it to the project proponent is there's a lot of I think that's problematic, and so there's different sources we're looking at. Some of it is Leroy Westerling, possibly Max's and Michael Mann, I think.
Yeah,
came out recently with a probability analysis, and so yeah.
So why don't we do this for this step? Why don't we collaborate with you guys in terms of trying to figure out what the best methodology is, or what you guys are going to adopt, and then we'll just integrate that into the protocol. That way it's consistent.
Yeah, I was actually looking for your comments on this one specifically, because we've been wrestling with it with ARB the most.
Yeah, it's tricky.
Yeah.
Yeah, this is not an easy one.
And this is where you'll get the biggest criticism. So getting this part right is important.
Yeah, well, for us, if we're able to leverage
Yeah, exactly.
with a policy decision, make our lives, that'll be a huge conversation for us. And Bruce is happy. Being quiet. Okay.
I think in general, we're at least for like GGRF, we're going to have to lean, if we're leaning on the the Westerling or Moritz or in some combination, looking at the
modified version of it, or
like a modified version, exactly. Yeah.
Right, where it's basically pinned at this, actual expression of the last 10, 15.
And then going back to what Russ talked about earlier with the weather data, when you guys are talking about it, are you talking about it changing with climate change over time, or are you looking at these things? I know you'd like to, but is that,
No, I think I think the approach would be that if this model is dynamic successfully over time to reflect maintenance changes, absolutely, burn frequency would be one of them.
Because I know Mann and Moritz, their approach actually has climate change built into it.
It does, and again, I think as Dave said, I think it's important. If the model is dynamic over time, then you have to do that. But it also, we're incorporating that. I think we're going to try to incorporate
It's changing. It's clearly changing. And to use some static number across a 100-year kind of horizon, something.
Right, and some of it depends on project life, right? What gets deemed project life, whether it's 40 years with ACR or 100 years or whatever.
Are there any comments on the phone? Is there anybody left on the phone?
Yeah, actually,
we're still here.
Leroy's got a new paper out in Royal Society Proceedings B, where he updated the original science data set. So this is just looking at empirical data, and also included additional lands, not just forest lands. And you look at there's a figure 1 in there that looks at the distribution, or the total number of fires, natural versus human ignited, and then hectares burned, annual average, and you see these large decadal increases, right? And so I think that, whatever the approach is, it should use a fairly short temporal period to get at, because if you go longer, right, we've had effective suppression for a long time, which has helped keep fire size down or area burned down, but we're starting to lose that battle.
Yeah, but we also don't want to, we want to stick to numbers that are verifiable in the future.
Yeah. No, I agree.
Okay, no, that sounds like this conversation is a lot easier than I thought it was going to be. Use somebody else's stuff.
Like Ashley said, this is ripe for controversy.
Oh, we know. That's why we were trying to put some time aside for this conversation. A large chunk of time aside for this conversation.
Totally critical.
It is the magic sauce.
Yeah. Thanks so much.
Yeah.
Well, there's two parts of it, right? So the one part is figuring out what that time period is, right? The second part is figuring out how do you discount it over time, right? So the way that we've talked about doing it beforehand is the Weevil distribution, which is that graph I showed beforehand. There might be other approaches as well.
I mean, I think you sort of have to work back from if there's 100% certainty it will burn, over, 100 years, or you pick some time period over which there's 100% certainty that it'll burn, and then you walk it back, reducing that certainty to something where there's comfort. But that's what I mean. You guys have been doing this, and I feel like we should basing someone off the TGRF protocol, but potentially push it a little, because I think it's important to kind of push it based on studies that have come out this year that weren't available when the discussion started. And I think if you can push it a little and get acceptance by a wider group before it comes to ARB, I think that actually can make a big difference.
Let's do that.
Yeah.
Let's do that. Okay.
And it's not just a matter of when it burns, but how it burns.
That's true.
Yeah, you have a couple of different factors in there, right? That when it burns, but to how much you lose, essentially, yeah.
Yeah, the how it burns is built into the other boxes. The probability of its burning was one that we wanted to call out on its own. But yeah, you're right. How it burns is definitely part of the conversation.
But the good news is we're measuring number, size, and intensity and location over time. And so we can be constantly looking at the trend line. We know the trend lines are up, so how much up? We're constantly measuring that. Publications on it.
That'll be an important question.
Not really intensity, not really measured consumption. You're inferring a lot of that from the severity mapping.
Yeah.
And, it's not, there's issues with severity mapping. It's very, the large blocks of classified data. It describes effects on vegetation, and the effects on vegetation as a function of the vegetation structure. Also impacted by fire intensity, sure. But in some cases, you do those overlays and you get some funny results that you don't anticipate, and then you backtrack it, and it's an error in the structure data from the veg map.
Yeah.
So.
But that stuff's getting better. So being able to track it, like going to Steve's point, the technology is getting better. Being able to track it in the future is going to get better. So this is something, going back to the verification element of things, when we model things out, there's mechanisms that are getting us in place where we can start calibrating.
I have a question about you had a slide that had density on it?
Which one?
Had a couple curves. Yeah, there we go. What is density?
Comment.
It's again, these slides are related.
Yeah.
Left is annual probability, and then when you add the annual probability, when you sum it up for a given year, that's how you get to the right side slide.
Yeah.
It's statistics. It's probability statistics. It's nothing to do with forest.
Oh, yeah, it's not biomass.
It's basically the cumulative probability.
Yeah, exactly. So if you don't mind, I would like to move on to the last two steps in the accounting, since we're running out of time. And I don't know how fast we should go through this, because I want to make sure that we have at least some time to talk about the next 2 weeks.
Okay.
And what to do. So last step in the boxes in actually calculating separate accounts is type conversion. There are indications that this is a map again. The fire is actually in the project area that we're looking at. It's not very clear, but the red outlines are recent fires, last 10 years, I believe. And there are these two locations that show up not just as having a fire in the last 10 years, this up here, but also this one down here. These are all the two locations that show a change in vegetation type. So the big question is how we can account for this change in vegetation type.
What bars were those?
Red and power.
Red and power. How we can predict, or with a reasonable certainty, how much of the landscape would have converted if that fire would have hit. There is no good data available in the end. You would rely on literature to make a case for a given case study. Another option here is to really restrict our current effort for this protocol to California, that we actually provide lookup tables or some must-have factor in here for type conversion. So that's still an open conversation. I'm mindful of the time. I'm not sure how much time we can spend on this right now, or if we should push that back into actually your comments over the next 2 weeks. Any strong feelings?
Thomas, I would suggest that at least just looking at this image, that that's not, there is not type conversion in either of those, at least on about 5,000 acres of each of those combined are us, and that didn't get type converted at all. It's conifer forest now, and it was conifer forest before the fire. It's just current density is such that it's not showing up on this image.
So you're basically saying this is a misclassification.
Yeah, those are not, I mean, at least, well, wait a second. Those portions that were owned by us, I'm not entirely sure I could say the same thing about the portions that were owned by the Forest Service.
Go ahead. Yeah. Well, I think it's important to, when you're talking about type conversion, you're talking about long-term change to vegetation type, not just, setbacks in terms of like a, forest. There's going to be a succession of, if you have a high severity area of vegetation returning to that, but whether or not it, in a reasonable amount of time, an expected amount of time comes back to a forested type is a different thing than, and that's the question, how much of it is going to stay.
And that will also differ by ownership, I would assume.
It differs by ownership, but it's also differing by elevation and some other things, because you almost have to differentiate between type conversion that's going to be a factor of things that you can't control, and other things, and type conversion that is because you're not doing aggressive follow-up with planting and maybe some vegetation control and that kind of thing. So, that's the complexity that you'd have to deal with. If you're getting down into the lower elevation close to the oak woodlands zone, you may not have any control over type conversion, because there may not be any way that you can put enough money into the follow-up to ensure that it's going to continue to be forest. And and it's sort of a continuum as you move up in elevation.
Somebody on the phone? Oh, okay. Yeah, one of the ways of dealing with this too is actually identifying what where those ecotones are actually located.
Yeah.
And then once we know what those ecotones are located, identifying, going back to what you're talking about, those lookup tables, that would identify a potential change in the existing succession.
Well, and the beauty of this is that the project proponents would be able to now get credit for taking aggressive follow-up action versus what might be happening in the baseline scenario.
Well, I think you would probably want to set some standard as far as like how long in the baseline base case scenario, like 200 years from now, is it going to be forced again? What is you're going to have to define it.
And again, there I think the question is, do we want to think about this as a general accounting framework, or do we want to think about this in a fairly narrow sense of this protocol, potentially ACR protocol with 40-year permanent requirement?
So in 40 years, is this forest going to stay a forest?
Yeah.
Mm-hmm.
And you also have to add a wrinkle, which just came up. In both of those cases, the 2,500 acres that SPI owns are already in a reforestation protocol under the existing U.S. Forest Protocol. So they're already crediting for that work that was just mentioned.
Yeah.
Yeah, that brings a whole other set of wrinkles. Can you apply this methodology in a place where you already have an active protocol, where you're already getting discounts, where you're already getting a fire discount?
Well, you wouldn't already
get it. You can't double count. I can tell you that. That's one of their primary goals.
Yeah.
So then can you put a project? Oh, that's a whole separate conversation.
Well, no.
You can reconcile. Just reconcile.
Yeah. It's simply what you build into.
They don't get credit.
Yeah.
Okay, but you can take the difference if it's better.
Yeah.
On some other project, because there's interactions amongst, what happens on the landscape affects other portions of the landscape.
Exactly.
Yeah. See, in this case, there wouldn't already have been credit for the reforestation because you'd be building that into the project up front, and you would decide whether you wanted to take credit for it under this protocol or under the other protocol.
Right.
Which, if you were the proponent.
Let's get into the actual accounting.
Yeah, let's move on.
We have 10 minutes to go through a lot of accounting.
So, we sent you all a Excel spreadsheet that is the draft template and how you could do this accounting, how it walks, how the whole process could walk to the accounting. The example that this spreadsheet provides is based on the plaster study from 2012, that was called the USFS standard approach with a fairly low impact harvest up to 30 inches DBH, retain 40% of canopy cover, residual fuels removed. So I don't want you to focus too much on this example itself, but look more at the accounting as it works itself to the whole process. Anything else that I should mention with the treatment here for the example, Bruce? So what I can do is I can just leave this slide up here, and perhaps looking at the time that we have, that's the way to go. I could also pull up this Excel spreadsheet and show more interactive, basically the impact that the different accounting steps have on it. Any preference? So we'll just quickly walk through this one. You have the baseline for stock and growth accumulated up here.
I have a question about that.
Yeah, go ahead.
So the assumption here is that over 40 years it's going to double in the amount of carbon for baseline. I think we're finding through observations in a lot of recent studies that the overgrown forests are pretty much already at carbon carrying capacity and are in fact losing carbon. And so baseline over 40 years could actually be decreasing instead of doubling in size under these conditions, especially as the climate gets drier.
Yeah, this is just an example. Where we chose in the Tahoe National Forest, this is what the growth equations show. It's what FDS shows. Whether or not it's realistic,
right.
Who knows?
Seen a lot of modeling studies, but the observations are not backing that up, and so I want to flag that as a problem with this model, or the way they're running, or at least from what I've gathered.
So is this a critique of FBS? No. Are you critiquing FBS?
Yeah. Okay.
But it's a matter, I think, what's important there is if you have to calibrate FBS to what you expect the growth rates to be from the particular site that you're looking at. So I think that what he's saying is that the older, overstocked, dense forests that are, we may be overestimating by using sort of the vanilla FBS, maybe overestimating their growth as opposed to.
Let me jump in for just a second. I think that the statement that's being made is not being made as a result of the measurement or growth expectations. There aren't any forests in California right now that are so overstocked that they won't increase in carbon substantially in 40 years. But I think what the person's saying is that the effect of increasing carbon and fire and mortality and other things may be underestimated but that's not a fault of the growth model. So I can assure you right now, FBS is an extremely conservative growth model compared to others that are actually more data-driven and actually measured and proven. So SPI doesn't own an acre that won't double in standing carbon in the next 40 years. And we have a lot of land that you would say, looking at it from the outside, is heavily stocked. So the stocking levels that we currently have are not at the point that growth will not net increase carbon. The question I think that's being raised is how sustainable that is in light of other aspects that are changing.
I think what the study that Nick's referring to is, one of them anyway, is our work out at down at Tea Kettle, and basically what we found, and when we looked at the control plots at the 10 years after the treatments were implemented, is that we actually saw a decline in the live tree carbon stock. Total ecosystem carbon decreased a tiny bit, but there's a substantial potential there as mortality increases for net carbon loss from those untreated stands, and that's a fire-suppressed old-growth mixed-con forest, and and so I think that what Nick's referring to is probably more applicable. I'm sure it's way more applicable, Ed, on federal land than on any SPI land. But any area where there hasn't been some disturbance or harvesting on federal land, and you've got this kind of aging of the stand, and then that fire suppression layered in on top of there, I think there is a real potential there, particularly with increasing drought frequency, for an overall decline in total ecosystem carbon.
I think that's true, but that's also, if you looked at the total land base of Sierra Nevada, that's actually the rarer condition.
So,
the more common condition is the second growth forest that's got a lot of room to keep growing.
Sorry for cutting you short now, but I want to raise two things here, just also to be mindful of the time. One is, this is the example, we shouldn't focus too much on these numbers right now. Second thing is that this line of that increases, that shows you this increase in stocking, does not account yet for fire risk. That's what's coming in as a second or some
fire chance.
Yeah.
Well, actually, fire risk.
So this fire.
That's an effect.
A lot.
So, again, just to move forward here, we have the baseline that looks at a forest stock and growth over time, over those 40 years. And in the next step, we look at fire probability that's affecting this, stock, and then we get to the total cumulative carbon that's stored on site in the baseline. And now exactly the same happens for the restoration project, where we have projections on forest stock and growth, including the thinnings or fuel treatments that we implement. We include here the shadow change effect and the direct emissions, of course. We look also at what's removed in slash. That's basically then also funneling into benefits from bioenergy use. We are looking here right now, just again a disclaimer, this is the full accounting. This is not necessarily endorsed in the end by ACR, because this for this wildfire avoidance emissions protocol, because the bioenergy component might need to be checked out. We're looking at mentionable wood removed and how it traces its lifetime through use and post-use in landfills. That's the next point here with mill rate. We have, again, a placeholder here for what product substitution LCA, meaning if wood replaces the use of more fossil fuel intensive products like steel. That's a contested concept, not right now included in the ACR protocol as we have written it out, but in here as a placeholder, so we can play around with the impact of it on the overall accounting. And then all the way down is avoided type conversion that we just talked about. And then the last three lines are adding this all up over time. That's the third last line. And then the very last line is actually the one that I want to focus here just for the next half minute on is the credits that you could claim on a per acre basis every 5 years.
For the fire shed.
For the whole fire shed. So these credits, as they show up here in the very last line, on a per acre basis, basically the tons per acre, and you would multiply that with the size of the fire shed. And for the very first 5 years, you have savings of 1.62 tons, metric tons of CO2 equivalent emissions per acre. You could multiply that with your acreage size, or with your fire shed size, and you come up with the credits that you claim for these first 5 years, and that you could request for payout.
In this example, the fire shed size was 10,000 acres.
Yes.
And in this particular example, you didn't have intermediate treatments either.
No.
One treatment. One treatment. Yeah. But the values are per acre. Your modeling was a 10,000 acre area, but the values on this chart are per acre.
Exactly.
And it's per acre for the whole fire shed. It's not per acre treated.
No, I understand.
Yeah, so when you want to calculate out like what the potential revenue is, or what the potential net impact is, you just multiply it out by the size of this fire shed.
Again,
And in a conventional thinking, the owner, the treatment agent pays for all the treatment, but only gets the benefit on their acre.
No, it takes benefit over the entire fire shed.
So would you be? How would you be getting credit? I understand the shadow effect, but how would you be able to claim ownership of a credit that's on somebody else's land?
So I think this is a conversation. We're looking here right now at the whole fire shed and how you can calculate the credits across the whole fire shed, across several ownerships. I am absolutely with you that then comes the big question, and who in the end gets the money from those credits? Who implements these treatments, to what intensity, how much money is spent on the treatment by ownership, and then who can claim these benefits?
We don't want to follow the water law in California. We want to follow some other sort of paradigm.
And I guess what that comes to is a conversation that probably then each project would need to fill with.
So the idea
that would be entailed at least in the protocol.
So the idea is that, for example, if Forest Service is putting all these treatments to protect SPI land and SPI land doesn't burn, the avoided emissions would go to the Forest Service for actually putting in those treatments, and vice versa would be the case. That's just the idea. No one's approved it. I just think it's a nice idea.
And in a real world, the only way it's ever going to work is that both parties are cooperating, because the fuel location strategy and everything else is going to be independent of ownership.
Yeah.
So it's going to be a cooperative. If you do this effectively, it's going to be both parties will be working on the solution, and somehow the investment that it takes to accomplish the outcome would be the way you would split the reward.
That's the ideal. That's the ideal situation.
The discussion on who gets the credit, though, has come up in the context of other OPSA protocols, so it would be wise to just take a look at how they do it and be consistent with it. And then there's a discussion at the international level right now on the same exact topic as they try to redo the development mechanism, too. So it's worth, we don't have to match international protocols, obviously, but it's just worth looking at that debate a little bit.
We're doing one, so in Indonesia, we're working on Sinarmas's fire program. We took over that program. We're in the middle of that conversation. They the private industry, government, and neighboring parties, none of them agree.
Right. And not that you guys disagree, you don't need to delve into that.
We don't want to use that much.
Right, but it would be worth doing a little discussion on just why you would argue for who gets, who gets to claim the credit, essentially.
So where does, in terms of this conversation for wildfire machine that you guys are using, what direction is it?
I don't think that there's a firm direction at this point, because we haven't made it that far. As you all have.
Like jump it and grab it and move it along with it. Okay. We are 2 minutes over our break, or our cut time, right? We go to 12 or 12:30. Oh, damn. Okay. Why don't we do next steps, and then we'll close the meeting. Okay.
Next step. So we were hoping that you could provide us with written comments in the next 2 weeks on the protocol itself. We will work on the comments that we received today in the next 2 weeks as well, and we'll actually try to respond and provide you with a comment and answer included document in 2 weeks with everything that was discussed today while you work on your comments. If we don't hear from you in the next 2 weeks, we would assume that you're okay with the protocol as it is formulated right now.
Let me elaborate on what Thomas just said. So one of the things that we'll kick out relatively quickly, hopefully the next day or two, are the notes from this meeting. We'll get that out so that everybody has it. We would, and just to reiterate that one thing that Thomas said, if you do not make comments, we're assuming that you accept the protocol as it currently stands. That's going to be our default just for mental sanity. After 2 weeks, we're expecting to get all the feedback that we get from this meeting. And please do not be shy. You're not going to hurt anybody's feelings. Constructive criticism is really, really appreciated. So any thoughts, concerns, please bring them up. It's really valuable for us. We'll integrate all those together. We'll review it with our internal science team, with our internal reviewers. And then we'll kick out what that draft report is, again, out to everybody for a second review. Does that sound like it's okay with everybody?
Yeah, who do we send the comments to, David?
It directs everything to Thomas Volkov. And okay. You should have his contact information. If you don't have his, or everyone's welcome to CC me on absolutely everything. Keeping in mind, I will forward it to Thomas. But it's good to hear from you. But yeah, send everything to Thomas.
Okay, thanks.
Okay. With that said, thank you very much for your time. This has been productive, especially for us. We've learned a lot about some of the concerns and approaches. Some of these conversations have made our lives a lot easier, and some of the conversations have had the complexity. And again, if you do have any questions or comments or want to pick up the phone and chat with us or email us, please do so. We're very, very open to communication, okay? Do you guys want to add anything? No. No, covered it. Thank you, guys. Thank you very much.
Thank you.
Thanks, Thomas. Thanks, David.
Thanks, guys.
Way simpler than I thought it was going to be. Just kidding.
You just started adding boxes on me.
I was just kidding.
Uh-huh. I know you're just kidding.